Hello everyone and welcome to another episode of the WeAreDevelopers Live Days. My name is Benedict and I'm glad that you're all here today. So today is all about Python, but before we start with the first speaker, I have some information to share with you. First, together with our partner Deloitte, we have a giveaway. You can win a MetaQuest 2 VR gaming headset or 1 out of 10 goodie bags. To attend, just scroll down on the page. If you're watching on YouTube, follow the link in the description for the full experience to our site and sign up, and then you're good to go. And also, if you are a regular viewer or even attended some of our events and matters, you certainly know that we have a soft spot for our rubber ducks. And some time ago, this happened.
Would need to say makes the web better place still for at least the next 500 years.
You probably recognized him. Yes, that's Håkan William Lee, the inventor of CSS, casually signing two of our rubber ducks. And the best part is you can win both of them. For the first one, just attend a naming competition on our Twitter. You find the handle right here. And for the second one, just sign up for a Dev Digest newsletter. You can find the link in the comments. And now, back to Python. For our first guest of the day, Steve, who is Senior Developer Advocate at Lumigo, with his over 20 years of industry experience, he's an established speaker who loves to share his knowledge. Welcome, Steve.
Hello, so amazing to be here. Thank you for having me.
Hi, Steve. Yes, thanks for joining us today. I think you're certainly well armed for today, as it looks like.
Oh, I see what you did there. I am. And everyone might be wondering why I'm wearing chainmail, and that would be a good question because I don't know. I just wanted to make it a bit fun.
So, Steve, what are we going to learn from you today?
Today, we're going to debug Schrodinger's app, which is going to be, well, I've got a couple things planned. And as developers, I mean, we're all a little bit magic. This is kind of why I'm in the scene and dressed a little bit wizardy. Because, yeah, we as developers, we love building out and using our magic to build out applications for people. So anyway, we're going to be playing with some apps today and breaking them, which is always fun.
Steve, that sounds very amazing. But before we start, just a quick reminder to the audience, feel free during the talk to interact in the chat to your right. But remember, be nice to each other, respect each other. We have a short code of conduct. Here's a short video about it. All right, and after this, Steve, the stage is all yours.
Amazing, thank you, and hello everyone, wherever you are in the world. I hope you all well and learning all the things, geeking out, breaking stuff intentionally with the idea to fix things and make things better because that's what it's all about, and that's what we use our tech superpowers for. As well, actually, if you're watching this beyond this live event, hello from the past. I always love saying that because it's always a nice little message from the past. As Benedict said, if while you're following, if you're watching me live, please drop all questions, comments, and emojis into the chat, and we'll answer them as we go. Although I'm a few screens away, I'll flick back occasionally, and I've got some demos planned. Hopefully they work. They should work, and if not, I know how to debug them, so it is fine. Yeah, please drop all comments, questions, and emojis in the chat as we go. If you are watching this in the future, hello again from the past. Please reach out on all the social medias. I am known as Developer Steve pretty much everywhere, so I'll get into that in a little bit. I do have a disclaimer, and on the whole topic of wearing chainmail on a live stream for fun, because why wouldn't you? Funny story, this one time, I'm going to have a lot of these. This one time, many years ago, I decided to see if I could make chainmail because, well, I like Dungeons and Dragons and role-playing games and stuff because it's fun. And I wanted to see if I could make chainmail. turns out I did. I made this myself. Took a long time. Took a while. It's all hand cut, hand wound, hand cut and stuff. And then kind of wondered, what do you do with chainmail? So it turns out you use it on live streams, because why not? Anyway, I actually do have a disclaimer before I start. And speaking of fun, I do like tech jokes. So I have a whole bunch of these. So, and there's another one. I'm not going to give you any spoilers. Anyway, you'll all see it. But anyway, how do fallen trees check for errors? Via log files. There we go. Hello. I didn't say they were good tech jokes. Again, please drop your emojis in the chat. Hello, so my name is Developer Steve. I'm one of the senior developer advocates at Lamigo. I've been in the tech industry a long time. So long sometimes I feel a bit old maybe. No, I just adjust my daytime clock, it's fine. But I've been around the tech industry for many, many years now, being able to geek out as a developer advocate or developer evangelist with developers and tech folk all over the world, which is really amazing. One of the things, as Benedict said, one of the things I love doing is, well, like the open source approach really, is sharing things I know and learning along with the communities, which is always great. And again, if you're from a particular community and you're looking for someone to come do a talk or just to geek out or just to reach out, please hit me up on social media. I am Developer Steve everywhere because that is legally my middle name. Funny story. There's a few of these funny stories. Anyway, I got married in 2018. That is my wedding photo on the top right. And we combined our surnames to create a whole new surname. So Kuchin is my married name. When I legally changed my name, because I've been a developer advocate for so many years, people just started calling me Developer Steve. And I thought, you know what? I'm going to make it my middle name. So my full legal name is actually Stephen Developer Steve Kuchin. So I do get some funny looks sometimes when people realize that. So on the passport and your cards and things, it's actually on there. So anyway, yeah, everyone just called me it. So I thought, you know what? I'm just going to make it my middle name. So there we go. Anyway, we've got some fun things planned today, including 2 demos. Well, actually, there's a multiple of demos in 2 different sections of the demo, just because I like sometimes really testing the Murphy's Law of demos. So we'll see how we go. But I do know how to debug it. So if anything goes wrong, I'm sure it'll be fine. Actually, spoilers, I have intentionally broken the app, but we'll get into that in a little while. So like I've been saying, I've been building apps for many, many, many years now. How long, you might be asking, or you might be thinking, anyone remember QBasic back in the good old Atari 800 Excel days? That was what I first learned to program on, which was great because, well, it was basic. Anyone that's familiar with it, just like its namesake, it's pretty basic. Like, it was very fundamental, and all good, all good adventure stories really have to start somewhere. And for coding as an industry, as an institution, if you will, this was development and the development origin story, the basic days. Didn't have a lot in the way of libraries. You literally had to rebuild everything, but there really wasn't an internet or an open source community per se, a global open source movement like we have now, and everyone contributing. Always contribute. We're going to talk about that in a little bit. But yeah, I've been coding since the age of 8, just building little tinkery little apps on an Atari 800 XL. If you are on the live stream right now, please drop in the chat what your first computer was and what you first started programming on, just because I always love just hearing how people got started and humble beginnings, just, hacking away, building little apps, tinkering little projects. And over the years, I was able to build on those skills and really start to build out applications as the industry matured. So building out into and growing my own career, my own pathway through to digital agency, building out all sorts of applications. Actually, I really like digital agency because it really puts your skills to the test as a developer. I always call it organized chaos because you're literally pitching on, with one hand, pitching clients and trying to help, land work. Even as a developer, you're always like, giving estimates on time and building stuff out. And then on the other hand, delivering the things that you've said you would build out. And sometimes when sales sells the things that you can't actually do or don't really have, trying to hack together a solution, you always come up with some of the most innovative stuff under pressure sometimes. Sometimes it's just a lot of work. Anyway, And of course, one of the things I've sort of dealt with over the years, well, not dealt with, but moved along with the industry as we've built out into the cloud ecosystems, which has been great because as a developer, I can build out my little application. And if built right into the cloud native way, it can build out to really, really scale. And scale is the key, particularly early on in any project. And this is something I've learned, well, I've learned the hard way over the years, because you've always got to build, even those little projects that you start building out, you're always got to build with that scale in mind. And in particular, when you think about it, and anyone that's ever deployed a project that's suddenly received a lot of growth in users or application functionality, from that first get init, that first time you start to create that first repository and start to build out your application, even just deploy that bootstrap to start building out a project, you're incurring that tech debt, and scalability is always at the forefront of that. So many times I've seen applications and amazing ideas at hackathons and all sorts of developer events around the world where that scalability isn't adopted from the very onset, and having the right tools in place, being able to, well, particularly debug and trace, but also on the security side of things too, like having those fundamentals right at the start will help you scale later on. You're literally paying the tech debt forward and pushing it away. You're not going to be immune from it, but at least you can mitigate a little bit when it is a problem. Another way I like to think about this is also the Friday night rule. And this also applies for all those times when someone goes, which is the right language to use? Which should I use to build out this particular application? The Friday night rule always comes to mind, because no matter whether you're having a quiet drink on a Friday night after that long week of deploying and building out applications, or you're halfway through an online game and maybe you're in playing Fortnite or Minecraft or some sort of online game, and you get that message on Slack at, I don't know, midnight on Friday night. Well, that'd be Saturday. You know what I mean? But you get that message saying the application's down, and you're like, no. Well, my Friday night rule is, if you can support it on a Friday night in those sort of circumstances, it's the right thing to use, and you've got the right stuff in place. Again, having the right stuff in place from the onset is paramount to being able to, well, get back to your game or get back to your Friday night. Python for me has always been a heavy lifting language. It's that versatile language that allows you to scale mountains with a single bound, well, scale applications with a single bound, if you will. So, and there's so many different things you use it for. One of the first things I started using it for all those years ago was building out a game, or literally building out a game client. Always, well, coming from those nerdy origins, if you will. One of my friends was building out a game engine, but didn't have a client, didn't have a front end for it. So I was like, yeah, I'm good with code. Let's see what we can come up with. And literally building out a multiplayer online game or a text-based game was one of the first projects I ever did with Python, which was amazing because I used Tickle, what was it, MMPRG, and I used Tickle to basically build out a bit of a nice graphical interface so that users could kind of see what was going on in the game and know what was happening. It was a bit dungeon crawlery style, and ran through some servers and things. But the thing is, it worked, and I had fun doing it, and I learned so much being able to do it as well. Over the years too, building out APIs. Oh, I love APIs. I could go on for hours about them, but I'm not going to. APIs sort of allow these sort of applications to be built out, because as we know, they're the glue that binds everything together and keeps everything secure, as long as they're built right. But APIs as a whole, well, they're kind of fun, and I've worked with them extensively over the years, as I'm sure everyone here has too. Python really does, as that heavy lifting language, create a nice fundamental groundwork for APIs to be able to be built out. Of course, data science, no secret here, because, well, we see it every single day. With the number of projects I've used over the years through a number of different companies, being able to build out machine learning or even graphical charts and stuff, amazingly good. Python's amazingly good at that. I was trying to think, there's a Facebook /Meta just open sourced an AI library recently. That's what I was trying to think of. The name eludes me. If you know it, put it in chat because it's going to bug me the entire presentation. I'll circle back to that one. Anyway, if you know it, please drop it in chat because it's going to drive me crazy. Anyway, data science, Python and data science literally go hand in hand. It is one of the fundamental sort of key tools for data sciences, particularly in the machine learning space. Oh, it's right on the tip of my tongue. I can't think of it. That's going to bug me. Of course, for web stuff as well. Today, I'm going to be playing with Flask. I love Flask as a web server for Python. It's always been one of my favorite libraries, frameworks, framework libraries. Let's go with that. One of my favorite web-based approaches for Python, just because it's so light and extensible. That's not discounting Django. Django kind of makes more use of the heavy lifting aspects of Python in my mind. That's just my opinion. And of course, IoT, Internet of Things. I also love IoT. So many tech things, so little time. I've been 3D printing some stuff lately too, but whole other story. Anyway, IoT and MicroPython, of course, have had a long history together, well, as long as IoT has been around. One of the projects I've used it for, and there's been many, actually, spoilers, I did use it on my wedding cake. My wedding cake had its own phone number, and I built that the night before my wedding, because what could go wrong? The important thing was there was no fire. Whole other story. Anyway, IoT, this is another thing I've built previously with MicroPython and ESP32. Actually, here's what I have here. Yes, I have IoT things in my desk. This one time, we got a coffee table. This is a few years ago now. And I looked at it and thought, that looks like a giant iPad. I should put 300 LEDs in it and connect it to my home server and control it through a voice thing. So I did. That was kind of fun. Anyway, hacky little projects. There it is there. You could change the color of my coffee table. It's great. Anyway, that's just shows the versatility of Python, though, is you can use it for so many different things. Which brings us to today's topic, because this is something I've been pondering a bit lately, which is around, well, Schrodinger's rules of observability. And for those that don't know what they are, Schrodinger's cat is a thought experiment that basically illustrates the paradox of quantum superposition. Now, we're not going to go into quantum today because that's a whole other topic. Actually, QuizKit, the IBM quantum computing library, it's written in Python, or it's based on Python. It's mostly written in Python. Anyway, whole other thing. Check it out if you're into quantum things. And Schrodinger's cat, because quantum things is cool. But we're not here about that today. Essentially, Schrodinger came up with this theory around superposition and quantum mechanics, in that if you place a cat in a box and seal the box, essentially, well, sometimes in certain variations of this, there's radioactive material in the box and not radioactive material in the box. Point is, if you close the box and with the cat in it, you don't know whether the cat's alive and dead. So technically it's in a superposition state. So it's both alive and dead at the same time, which is, it gets into the path of quantum things. But this also applies to development, because if you don't observe a deployed application, well, it's both bugged and debugged at the same time, but bugs could be happening and you don't know without observing them, which kind of brings us to today's topic. Because Python, being that one of those mature industry languages that have built out over the years through all those amazing contributions and community that's built up around it, also has that Schrodinger's cat issue or approach, because, well, as developers, particularly when we're building out apps locally, we debug our applications. And in Python, there's a number of ways to do that. So core debugging inside using the core framework tools, for example, you can use things like print, which, well, let's face it, everyone uses print to debug stuff out. There's other variations of that too. You can use logging warnings, for example, to basically debug code as you're going through. These things are really handy when you're going through if-else statements, or in a certain part of logic that you want to see an array that might be outputted. Actually, I've got a library that'll help with that in a minute, arrays, dumping out arrays. But essentially, these are core tools to find out how your application's doing and help you build it out better. PDB is another tool, particularly for live debugging. And then, like I was saying, you also get into library debuggers like pprint, for example, which I'm a big fan of. I use pprint a fair bit. And you can also get it in IDEs as well. So debuggers in some IDEs like VS Code and Eclipse, for example. And these, as Python developers, these help us build out our applications because we can locally be able to, well, handle errors and output various aspects of our application while we're building it out, and be able to see things come out through the console. The Flask app we're going to be playing with today. Oh, there's another tech joke here. Can you see it? We'll get to that in a sec. The app we're building out today, I've called Schrodinger's app, and it's literally it's a Python to-do app. Python Flask to-do app. We'll get to that in a moment. Actually, let's do the joke. But this is a to-do app, and we're gonna have a look at debugging some stuff in a local environment, and then we're gonna look into some cloud stuff. Anyway, what do you call 8 bits in Python? Drum roll. Oh, I should reach for my drum roll sound. I have a drum roll sound, but it's a few screens away. Anyway, what do you call 8 bits in Python? A snake bite. Oh, there you go. I didn't say they were good jokes, but they're open source, so please feel free to share them with everyone. Everyone needs to always be smiling, so share this with someone on a Friday afternoon. That always goes down well, particularly if, no, we don't let friends deploy to production on a Friday. Anyway, the application we've got here today, these are some of the basic aspects of it, but I've got a couple little things coded in for us to play around with. But essentially, we're using Flask. Again, big fan of Flask. And we're using Alchemy as well to handle some of the database aspects. We've got a couple of basic routes just because it's Flask and Alchemy. We've got a basic get that's going to load, the website, and also any to-do items that are already loaded in there. Spoilers, there aren't any to begin with, but we're going to add them. Probably guess that. There's a basic post route, so this listens for a post HTTP coming in to be able to load the to-do items into the actual application. There's an update to mark them as complete. So, and if there's any text changes, the update is able to handle all that and then save everything to database to make sure everything's saved. Then there's a basic delete function, because sometimes we want to delete our to-dos. Maybe because they're done. I hope because they're done. Anyway, let's have a look at the app. Let's do demo time. Yay! Before we do that, I'm going to switch back to the chat to see if anyone's come up with nope, no one's come up with a name. That library is going to really annoy me because 2 weeks ago, Meta literally came out and said they're open sourcing it. Machine learning library. Oh, it's literally Torch. Oh, I remembered it. It's Torch. Yes, I love Torch. Anyway, I'm glad I remembered that now. It was really going to annoy me. So this is our application. I've got everything sort of saved in this, one routing file because that keeps it all, it keeps it kind of nice and tidy in one file, but I could have split that out into a couple of different files just as the application itself built out. Scale is always important. As you can see here, I've got a database model. Oh, there's 2 things there. I don't want you to see it. I've got a basic database model set up inside my Flask application. And then I've got a basic get, which pulls in a base template, just HTML template with some logic in that as well. The add route, which stores any post method or post HTTPs that come in to be able to create new to-dos, delete to-dos, and then update to-dos as well. And then we've got a couple others that we're going to look at in a moment. Anyway, let's try the first demo. Oh, I'm feeling lucky. Anyway, just refresh it to make sure it's still working, and it looks like it is. So this is a good start. Anyway, I'm going to enter my first one, just call it test. And, as you can see, it kind of worked. The best part here, let me make it a bit bigger. There we go. Best part, oh no, now it's going to, see. Oops, I spelled that wrong. I was trying to make it a bit bigger and be fancy, and then it didn't quite work out. There we go. All right, I'll do that one. All right, so, and as you can see, the routes come in. Oh, now I can delete one of those, and you can see the routes coming in as well. So there's a post coming in, and then there was that delete. I can also mark this as done, and then, finish, it shows up as completed. And on the database side, it's actually marking that as done as well. all looks pretty well and happy there, everything working as expected. Only in the developer world, as we know, sometimes things don't always go to plan, and while that app may look like it's working, potentially it is not. Again, this is Schrodinger's cat in action because, well, if we don't observe it, we don't know what's going on here. And here it's really easy in my local environment because I can see the outputs from the logs nice and easy. There's only one app or only one instance running, so it's fairly easy to be able to deal with. So let's try tempting Schrodinger's cat a little bit and enter cat. And as you can see here, I've got a bit of funky logic in here to do some fun stuff because we like breaking stuff intentionally, or at least breaking stuff intentionally and then telling somebody about it if it's not my thing. Anyway, you know what I mean. Here's where things are going to get a little bit fun because this particular logic, what I've done is I'm sending back a HTTP status equivalent to the number of cats that this particular app is, or this particular to-do item is recording is in the database. So if I click cat, for example, it just broke. And you can see inside the console, I've just returned a 400, which means route's broken. Don't panic, this is intentional. So if I click redirecting now, you can see there's one cat. If I do it again, just through a 401, because it's just going to keep incrementing every time I keep clicking the cat button, which incidentally only appears on the actual cat, at least with cats, now that there's two listing. See, I even loaded in the grammar inside the Flask template. Let's see, that. There we go there. Oh, there's some stuff in there that's coming up. Don't look at some of that. Anyway, but yeah, the bit that I wanted to show you for the template, so you can see the Flask templating engine. I'm able to pull out different logics as part of the template. What I've actually done is accounted for the, there it is there. Accounted for the S if the count of that particular field is greater than 1. And then of course on the cat route, I'm just grabbing that from the database, adding 1 to it, and then returning HTTP stat or status as part of sort of that increment number. So each time I press it, basically, it's going to keep throwing those errors, and it's kind of useful for tracing the app locally because I can test all these different HTTP statuses as we go through. Only it won't get to my favorite HTTP status. I do have a favorite HTTP status, incidentally. Drop in the chat and tell me what yours is. Mine's 418. So, and I can't actually get to it in this app because of a bit of a bug. It's kind of intentional. I mean, I did it to myself. It's a Schrodinger's cat trap app, cat trap. You know what I mean? But essentially, if I keep clicking this now, if I actually discovered this one earlier by accident, 7, oops, there we go. It still did it because that was 409. This one will be 410. Now it won't actually go past 410, which really annoys me because 418 is my favorite HTTP status. Oh, there we go, 411. It won't go past 411. Yeah, there we go. It won't go past 411. Yeah, because it's stuck on 410, which is HTTP status 410, which is client error message gone, essentially. Essentially, it's sending a message to say there's no client. 418 is my favorite because I'm a teapot. It means completely nothing. Yeah, it's just I'm a teapot. Anyway, this was brought in, for those that don't know, this is a legitimate HTTP status or a legitimate traffic status. This was brought in a number of years ago as a bit of an April Fool's joke and never left. It was talked about being taken out 3-4 years ago, and thankfully it didn't. Doesn't mean anything at all other than I'm a teapot. No explanation needed. Anyway, so fun fact, my HTTP status thing kind of has an accidental glitch, if you will. We won't go past that. But as you can see here, I'm able to clearly see the output from this application. And, well, I can cater for these particular instances of HTTP statuses to appear in my application. Let's continue on in the prezo, because there's more. But wait, there's more. I'm just going to switch back to the chat quickly. All good? Okay, cool. If you do have any questions, comments, or emojis, and you're watching live, please drop them in the chat. If you're watching this in the future, please reach out if you have any of those things on any of the socials. I am at Developer Steve, kind of everywhere. So that's where where things start to get interesting, because deploying this application to a cloud or to cloud infrastructure that we want to scale like super rapidly, well, it gets a little bit trickier to debug these type of things, because that error could be happening in 15 containers that are deployed in multiple regions around the world, or 15 different lambdas deployed in regions all over the world. Things start to scale a lot quickly, particularly when you're dealing with not only the deployment method, be it containerization or through serverless, etc., or through microservices, but when you start to also incorporate other services or third-party services into your application, those little tiny errors at scale are soon going to add up. And one of my favorite memes to sort of think about as well when you're looking at sort of scaling your applications from the early stage onset, those errors that you first had in your local environment, building out that application at scale, like that whole "it worked on my machine" things isn't going to work too well when you're dealing with the Schrodinger's cat of scale, essentially. And like I was saying, like those, when you think cloud native and deployable applications, those components used to scale out your amazing Python application can exponentially grow and also rapidly change in a fast-moving tech world that we know and love today. Those three components that to your application, be it that database or that broker, that queue system built into your app, any of the changes that happen either without your knowledge, or even configuration changes, or maybe even a new feature that's come out without observing your application literally turns into a sort of Schrodinger's cat. And that one error, again, if we go back to that Friday night rule, that one error that appears also in that one service, in that one region, in that one part of your code, could take you such a long time to actually find literally the proverbial Schrodinger's cat needle in a haystack box. I was just thinking that should be a sticker while I was saying. And of course, one thing I always sort of tie back to, particularly when these instances rise, is the Murphy's Law, if you will, which always goes great on top of Schrodinger's unobserved error rule. That Murphy's Law is always going to raise its head and essentially throw the unexpected at you when you're least expecting it. And this is where distributed tracing starts to break this down and make it a lot more streamlined. Because you can take a multitude of these services inside your deployed application and create a really nice system map, flowing system map of every call that comes in, every route that is called within your application, and make it nice and easy to be able to, well, navigate your way through the stack. Literally the unpacking of that Schrodinger's box, if you will, or that observability box. And if you think again back to that one service in that one application throwing an error from that one piece of code that may have worked fine in your local environment, you're able to quickly trace that particular service through to, or that particular error through to that particular service causing all the problems, and be able to identify what the issue is. Sometimes too, it's not uncommon for a flow-on error to occur in a system 3 steps beyond where it actually happened. Little bit chicken and egg, totally quantum mechanics, because that one error may actually be coming from 2 steps beyond where it's actually appearing, just because of the way those services and those cloud native application, cloud native services are working inside your application. And then, of course, the best part with this is you don't need to run agents to be able to identify a particular or be able to observe your application. Gone are the days, and I have pulled so many hair out over the years running an EC2 instance somewhere somewhere that's an AWS service, running a server somewhere on a cloud, and then having to also maintain or keep running an agent service to be able to observe my infrastructure and my application, either on the infrastructure itself, on the server itself, or on a secondary server that then observes all my other servers, or the one server, one production server, etc. Like the amount of times I've had to keep that agent running to be able to watch that stuff, so harrowing. Thankfully, there's some industry standards that help sort of govern, and we're going to look into that a little bit because it's completely amazing open sourced industry open sourced protocol to dealing with observability across a multiple of clouds and applications. You might be thinking, what, agentless? How is that even possible? Anyway, the industry standard is called OpenTelemetry, or OTel for short. Now, this is a movement that has been around since 2019 under the CNCF, or the Cloud Native Foundation, which is a vendor-neutral approach to open source observability. So essentially, this is one of those industry standard approaches to making sure that all the logs and all the metrics that are produced from applications and infrastructure that runs the applications is all made standardized so that everyone can basically use the same approach and the same methodology to observing their applications and making sure everything's kept nice and debug free, and you're able to, observe the cat in the box, if you will, and make sure that the stack is kept nice, error and bugs free. So OTel at its core, I'm not going to go through the full thing because, and there's some amazing write-ups on their website, on our blog, and some really great videos sort of goes into a lot more depth on this. But OTel, or OpenTelemetry, is essential in instrumenting, generating, collecting, and exporting telemetry data such as traces, metrics, and logs, and that's industry standard across a multiple of platforms. The best part is, and again, like I was saying, this is an open source approach to measuring applications, including one of our favorites, and what we're here about to talk about today, Python, which is one of the more mature instrumentation libraries or open source components to this project. Essentially, this creates like I said, a standard framework or standard format for metrics and logs across a multiple of languages, cloud environments, and infrastructure, so that everything can be kept all nice and standardized and, well, have very similar approaches built on the same fundamental frameworks. Python is one of those as well. And I just want to take a moment here actually to talk about the importance of contributing back where you can, including projects like this, using, we're all products of open source, taking the time to be able to contribute back to projects like this, particularly if you're using them. I know you all do. I just always love mentioning it. And it's always a great reminder if you already are. Thank you. Thank you for your contributions. But yeah, being able to contribute back, and Lamigo's proud to be able to contribute back to these sort of projects and help create and foster that industry standard wherever we can. I always contribute back wherever I possibly can, particularly if I'm using a particular thing, like Flask, for example. I do love Flask. Lamigo actually has we've got our own open telemetry traces as well, and I'm going to be looking at one of those in a moment with a deployed application. I've got another way to break that app, but we're gonna look at that in a moment. Of course, we've got a Python one, which we're going to be using today as part of this deployed application. Going to talk through that in a minute. Oh, and I'm going to mention Node.js. I hope that's okay. Anyway, they're the two open telemetry traces we have at the moment. These are libraries particular to Lamigo, and they've all been open sourced as well. So, fun fact also, I actually live in rural Australia. I don't know whether my accent gave that away, but I actually named one of it's lambing season here, and I named this one Lambda the Lamb. This is a keeper. You only name lambs that you're going to keep. This one's going to be staying with us for some time. So this is Lambda the Lamb, and he thanks you in advance for contributing stars to both of these open source projects or any of the others that have been mentioned in this presentation today. This is me holding Lambda the Lamb. I just wanted to include a lamb in my presentation because sure, why not? These traces are pretty easy to set up and get started. You literally install the package, just pip3 install. reference it in the code. We're going to have a look at that in a moment. This one, the configuring environmental variables, really, really important because friends don't let friends hard code variables ever. Please don't hard code variables ever. It'll drive you crazy, and that Murphy's Law and Schrodinger's cat in a box will come back to haunt you later because you have to go through all your code to find it. So please don't do that. Anyway, the two variables you particularly want to set, and I've already done this inside the application we're going to be looking at, is hotel underscore service underscore name. That just sets really nice name in your telemetry data that comes through. We'll have a look at that one. And your tracer token, which you get from your, let me go dashboard from settings. I'm not going to show you that because I can't change it. So I'm not going to show you my token. Anyway, again, please don't hard code credentials. So what we're going to be looking at in this demo, just did a quick time check and I should be good. But yeah, what we're doing, we're taking that same application. There's another function we're going to be looking at. I've containerized it, so good old Docker. Hey, there we go. And I've deployed that to AWS ECS. And I've also thrown in a queue because I thought it would be fun to throw in a queue. No, it's actually doing a couple of different things. And on the back of that, I've got a Lambda running that's reading from that queue. So it's the Lambda is being triggered once a message goes into the queue. We're going to be looking at that one in a moment. And then, like I said, we've got some OpenTelemetry data coming out as part of the containerization and also some auto tracing going on with the Lambda. We'll look at that and the SQS. We'll look at that in a moment into the Maker. Anyway, demo time number 2. I'm going to switch back and check the comments quickly. Yeah, we're all good. And it looks like I'm all online and there's no message from the admins, which is great. So like I said, I've already called it the library. I'm not going to build the container for this because I've already, Docker would kill my computer with all my fancy or wizardry scenes running and audio and things. But I already have it deployed and set up and running to get ready to go. The application we're about to look at that I've already got deployed already has the tracer, OpenTelemetry tracer installed and running. And that's all I need to mention here. That is literally the only thing you need to install for the tracing to occur. Anyway, I'm going to stop talking. I'm going to skip to my third window. Actually, I'm not going to stop talking. I'm going to keep talking on a different window. And this is my deployed application. And it loaded. Hey, we're off to a good start. No, I knew it was going to load. Anyway, so I'm going to, like before, I'm going to do another test so I can do very similar to things to what I did before. I can mark those as finished, completed, etc., which is triggering all the same routes. The thing here, though, is because this is deployed to ECS and it's set up with auto scaling involved, like as more traffic hits this particular application, more instances of itself will spin up and more logs are created, which is kind of a nice problem to have because, I mean, we build these as developers, as tech people, we build these applications for more users to come. Only when they do come sometimes and you're not ready for them, well, that particular infrastructure that you've deployed costs a lot of money to run because it's quite resource heavy. Like, again, this is where we go back to the Schrodinger's cat thought experiment, because that app at scale, unmonitored, could be doing any sorts of things and you'll get that really big bill at the end. It could be throwing errors. You don't know what's going on, really. So if I do the same thing I did before with the cat thing and start throwing the 400 errors like that, like the app's kind of still working, but I don't know what it's actually doing. And yeah, I can go into AWS and start sort of checking the logs that's being created off the back end of this. But well, again, at scale, those logs are going to get pretty, well, there's going to be a lot of them, and they may not all be in the best format to be able to, I'm glad people are watching. I was going to hide the IP address. Thank you in advance. That's great. Thank you for the comment. That was totally unexpected. The thing here is that those 400 errors are being generated by my amazing Flask app. I don't know exactly what's going to be appearing on the back end. with the auto tracing in place though, like I'm able to see, well, you can see here, I've got the cluster running. So this is my Schrödinger app cluster, and you can see some basic metrics being generated in here, along with some of the deployment specs and where some of the logging that's already come in from that particular app. But with that library installed, I'm also able to start seeing some of the traces that come through from within the container in the application itself. And so here's a good example of that, is that those errors that I was just generating with the 400s, you can see there, like some of them are coming through now. So 402, 403, can't get to my 418, which I'm really bummed about. I'm gonna have to build that in, like maybe I'll just add a teapot or something. But yeah, as those errors come through, like I'm able to trace through the application and see which route they're coming in on. Let's go to the invocation. I'm able to see more detail in the logging in a much clearer way on some of the information that's coming through. But wait, there's more. I do have another one built into this too. So if I go meow, you do a whole other bunch of errors, which is kind of fun. Actually, not really errors, but what this, oops, well, there was an error. That was an unintentional error. Wasn't that fun? There we go. I'll have to dig into that one. That one looked interesting. Anyway, I mean, it was intentional. Yes, it was intentional. So similar to cats with meow, if I keep clicking the meow button, it's doing something. It's meowing somewhere. What it's actually doing, and we'll switch back and look at the trace. And this is where sort of the open telemetry really starts to show its worth, show its weight. Because as those transactions come through, it's actually, what's actually happening is, actually, let's switch back to the code because I can show, oops, I can show you once I change those keys. But what I'm actually doing is sending through an SQS message through as part of that particular message function. So as I go through the, where's that? There it is there. As I go through and click meow, and every time it adds an increment to the meow, it's actually putting that meow into a SQS queue, which is also triggering a Lambda. And you can see that here, because if I go through one of the traces, there it is there, you can see it's the Flask app is triggering an SQS message to go into the queue, and some logs are appearing on top of that. So, and if I look through that, you can see meow number 3, which is the to-do number 3, but it's actually routing through and adding, where's my invocation? Let's go to, so you actually be able to see the post request coming through and then the value being changed as well, which is really cool because you're able to see there is there, meow 5. So every time I click that meow button, it's sending through a request, like through that particular Flask route inside the containerized application, putting a message into queue, which is then triggering the Lambda. And if any errors occur with that entire sequence, I'm able to see which step that particular error is occurring. It's easy as that. So now we have an outcome to our Schrödinger's cat conundrum, is that we know that it's alive because it's meowing into the SQS queue. There we go. Also glad that worked. Thank you for the person that actually lifted the IP address and added something to my application. Anyway, both my demos worked and I'm happy. Well, actually multiple parts of my demos worked and I was happy. Plus also there was an extra issue to look into, which is always great. I always love delving into these issues. One thing I did want to mention just quickly, and I know I'm pretty much out of time, is we also have a thing called execution tags, which allows you to dump pprint or post array data from your Python application out into your open telemetry and get even more data come through as part of your application as well. There's full write-ups on this on our blog and also in our documentation if you want to check it out, or reach out to me on socials and I can talk you through it. Actually, I did a video on this recently. It's kind of fun. Always fun breaking stuff intentionally. Let me say, yeah, let me do it that way. Just some takeaways as I wrap up because I am pretty much out of time. Always remember to build for scale. Build for scale from the start. You will save yourself so much headache and tech debt down the track. And well, like quantum entanglement, for those that are familiar with it, you can, I'm not going to go over it now. Anyway, please always build for scale. Make sure you always rinse, repeat, and refine, the 3 R's. Always take that code, refine it, and then continue refining it. Like, there's always ways to make it better, more streamlined, use less resources. Thank you, end users, they will thank you for it later. And also monitor and trace everything, APIs, SDKs, and especially deployed code, because unobserved code is literally a cat in a box. If you want to find out more about OpenTelemetry, please check out our blog, our docs, and our YouTube channel, because I've been recording some fun videos lately talking more about this stuff. And just finally, please always use your tech superpowers for good. I know you do. I always just love to wrap up on this, and be excellent to each other. Thank you very much.
Hey, Steve, welcome back on live stage.
Thank you.
I'm already a big fan of Lambda the Land.
Thank you.
Sorry.
He's getting a bit big to pick up now. He's a lot heavier. Like, he's 3 months older. So
they grow up so fast, the babies.
Oh, they do, right? Those lambdas just get out of control.
So, because just quick for the audience, because the question came up a couple of times, this live session is, of course, recorded. You can watch it right after at our website, and also every talk for itself on our watch section in some days' time. So, after that, Steve, you certainly looked like you enjoyed talking, so maybe let's talk a bit more in the Q&A. You ready?
Yes.
Steve, perfect. As we got a question from Max, who wants to know how to get a job without having business experience.
Oh, that's a really good question. Actually, I'm guessing Max is probably talking about being in development, maybe, or one of the things I always recommend for anyone starting out in tech is, like, contribute to open source where you can. Like, everyone benefits from it. Everyone's there's a lot of people always contributing to a lot of the main projects. And one of the things I love the most is, particularly for newcomers, is it's a great way to get involved, show what you can do, and get some industry exposure in the same process, plus help people, which is always great. Even from a non-technical point of view, reading README docs on open source libraries and being able to contribute back that way, always much appreciated. All contributes always welcome in most of the all the open source communities. So I would say get involved in open source. Short answer.
Yeah, it's connecting you to so much other developers out there. So I also think that's a very good tip. Maybe more general, when I introduced you to the audience, I told them that you have over 20 years of experience in this industry. Maybe you want to share do you have some key moments, key takeaways from these 20 years which defines you and your work, or you as a developer, as developer Steve?
Wow. Probably. That's actually a really tough question. Most memorable hackathon would have to be one that I was running many years ago called BattleHack Tokyo, where that was a PayPal thing. But some of the companies, one of the things I always love about hackathons in general is you always see some of the teams go on to become full-fledged companies or startups that then go on to hire other developers. And the fact that can come out of an idea, out of a 24-hour hackathon, I always love. There was so many that came out of the Tokyo one. It was just phenomenal. Plus, I got to meet Mats, creator of, we're on Python thing, but Ruby, I'm going to say it. There we go. I don't know if I could pick just one highlight. I mean, working with developers from all over the world and connecting with them daily basis is probably one of my most favorite things. I don't know if that sounds too cliche, but and just learning new stuff, like seeing the industry mature so much. Like these IoT things, so tiny now, you can build them into anything, you can build anything out, scale up clouds and build out ideas. It's so cool.
Right, thanks for that insight. We got a question from David. What do you think about all the hype about AI, ML, IoT? and quantum computing?
So I'm going to start with quantum, because quantum still blows my mind. And literally, if you think like traditional computing, ones and zeros, binary, like it's literally a switch on and off. Quantum takes that to literally a whole other level, because quantum moves away from that whole binary on and off with if you think of a three-dimensional object like a ball, or actually think of a ball or an orange, quantum, the outer skin of that is 1, and the very, very, very middle is 0. And quantum works in three-dimensional space in that entire sphere. Mind-blowing stuff, like just what that is actually capable of. And granted, it's still early days, but when we start to talk about entanglement, which is moving data across literally the fabric of space and time, is like crazy, crazy, crazy fun. Sorry, just reading message. It wasn't for me. The IoT, like to think like this is an ESP32 dev kit C, which you can buy for like literally like next to nothing these days. I bought, this is Wi-Fi enabled and getting quite powerful and low powered still. Like I bought an Arduino Yuan in 2014 for 70 Australian dollars, and these are now worth 3. So, and these are now all in consumer or smaller version of this, but consumer devices like light bulbs, kettles, well, just about anything you can imagine. I literally just put in a smart toilet, which has one of these in it, similar one of these. So anyway, whole other discussion topic there, probably another talk. IoT things like amazing because it's connected. It literally has connected the world around us without us even realizing. Like the amount of things you can now automate around you just using consumer off-the-shelf stuff is great. What was the other topic? That was 2.
Yes, there were about AI, ML, IoT, and quantum computing.
Oh, AI. AI, ML. So I spent 10 years, before I was a developer, well, before I was a full-time agency developer, I spent 10 years as a data analyst, and AI, ML sort of extends on things that I used to do with data, because AI is able to define all sorts of valuable insights from AI data, from large data sets, and ingest them and sort of spit out some really interesting groupings and commonalities between different sort of data groups. So previously, like I'd take, I don't know, a couple of million lines of customer data or customer transactional data and look for trends and analysis like manually and be able to sort of define and give meaning to a data set. AI ML is now able to do that without me even doing anything to it beyond throwing some modeling training sets at it. And it can come back untrained with a whole bunch of interesting statistics or interesting trends amongst the data that I may not have seen as a person. And potentially I can then refine that and sort of understand what it's saying that I may be missing. Like it gives more valuable insights that previously we were not able to get. Plus also automate. I love automation, like be it in my stack, like automating my debugging or automate my traces. Being able to automate the things around me, even my IoT things, which I have actually done, like at sunset, do this particular thing, and then I can use some AI/ML processes on the back of that to only do that if there's a certain temperature or there's a certain variable of light available outside. Yeah, being able to push the boundaries on that tech stuff's just always so much fun.
All right, Steve, we got one last question for you. Do OpenTelemetry work for embedded ENV and IoT?
That is a really good question. I'm going to say yes. I don't want to give any spoilers away, but I have a thing that I've been working on. Anyway, I'm not going to show you that. Thing that I've been working on for upcoming AWS reInvent in Vegas. I have some blog posts and some videos coming out about it, but yes, it does. I have some ways to do that. So stay tuned, because I have the 3D print, the IoT stuff, and all the server infrastructure, which will be going into a GitHub. So you can do it yourself at home. But yes, it does.
Very nice. All right, Steve, thank you so much for joining us today. Hope you enjoyed yourself. You certainly look like. And I wish you a nice rest of the day, which is quite short, I think, as it's quite late in Australia already.
Yeah, in the Wizard's Magic Cave. Yeah, it's already Wednesday evening. So, but yeah, thank you all. Thank you for having me, and it was amazingly fun to geek out with everyone. Please add me to socials and connect beyond here.
Steve, thank you so much. Bye. And before we jump to the second speaker of the day, just a 20-second break.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.
And right back to Python. Next guest of today is founder at Anvil. He loves making development more accessible, and in his spare time, he also casually flies airplanes for fun. Welcome, Meredith.
Hi there. Thank you very much for having me.
Hi, Meredith. How are you doing?
All right. Yeah, I'm looking forward to talking to you today. Anything you want to ask me about beforehand, or are we going to just drive straight on in here?
Maybe a quick summary what we are going to learn.
Sure.
It's always nice.
So today I'm going to be talking about Anvil, which is a platform for building full-stack web applications entirely in Python. So if you've ever looked at the mountain of things that you need to learn to go from, oh, hey, you know, I write Python, I do data science, I do backend, to becoming a full-stack developer, I'm here to tell you, one, that you are not imagining it. It really is unreasonably difficult. And two, we have a framework that might be able to help. And I look forward to sharing it with you.
All right, Meredith, thank you so much. Stage is all yours.
All right. So, hi, my name is Meredith, and I'm here to talk about Anvil, which is a framework for building full-stack web applications entirely in Python. And so that's really everything in Python, including Python running in the web browser, Python running on the server, even a Python user interface toolkit. And if I'm talking about this, it's reasonable to ask, okay, well, why is this a worthy endeavor? Why are you doing this at all? And to answer that question, really, we need to talk about the web. Because the web is, I mean, if an alien landed on Earth and we told them we have this great big global application platform that meant that anyone anywhere could deploy an application that could be used by the entire planet, they'd think it was fantastic. And then we would explain the actual stack to them and they would slam the door on the flying saucer and never talk to us again. Because web development is, I mean, it's really janky. Let's think about this massive complexity from the perspective of a piece of your data. So if you are at all familiar with web development, you'll know that most of the time, the data you're working with is going to start as, say, rows in a database table accessed by SQL, which is a whole programming language. And then you are going to immediately pull it out. The first thing you're going to do is pull data out of your database and turn it into objects in some server-side programming language. In present company, it's probably going to be Python, accessed by methods and attributes and so on. And of course, it's not going to stay there because your very next move is going to retransform that data into a JSON accessed over HTTP with this weirdly limited set of verbs like get, post, put, delete, which is really funny because on the other end of that HTTP connection is, of course, another program that's going to be reassembling that data into objects in JavaScript this time, and then turning around and rendering those into HTML DOM, which is a different set of objects, and then using this declarative programming language, CSS, to turn those into pixels on the screen. And that is a lot of different representations of your data just to say, hey, here's this piece of data, I would like to display it on the screen. And that's a lot of transformation to do. And like all programmers, we go, well, this is tedious and repetitive, so let's automate it. And so we invent frameworks to help us do this, and that attracts the wrong kind of magic. So to explain what I mean by the wrong kind of magic, I'm going to take like a really unfair pot shot at SQL Alchemy. So SQL Alchemy, if you're not familiar with it, it's a library that allows us to kind of automate the translation of these rows in the database table into Python objects. And instead of writing a SQL statement like this, I can instead write a Python statement like this. It's actually really cool, which is why this is a slightly unfair pot shot. Instead of having to write this different programming language, I can stick in Python. I can say, hey, okay, well, query book filter book.price is less than 20. That's nice. And that does ease the pain of all those translations. That is, the day-to-day work of any working web developer. But the process that takes that Python expression and turns it into SQL you can execute against a database is black magic. We're talking metaclasses. We are talking overloading Python operators to do something completely different to what they normally do. And that means it's a very brittle and leaky abstraction. If you naively try to put Boolean AND operator into that comparison over there, you will very rapidly discover that is not in fact a comparison as you think of it. It's actually generating some intermediate object that goes in and generates a statement in another programming language. And to use this effectively, you need to have all that complexity inside your head. And okay, in exchange for that complexity, we do get a bit of speed of development. And we can probably get away with this if we do it once. But if we have that kind of magic at every layer of this stack, well, you're guaranteeing yourself a bad day. And of course, that's exactly what we do. We have these ORMs like SQL Alchemy helping us translate database tables into objects. We've got REST frameworks helping us represent these objects over HTTP. We've got JavaScript frameworks like Angular's resources helping us to reconstitute that data back into objects from HTTP. We've got templating engines like React helping us turn those JavaScript objects into HTML DOM. And we've got CSS frameworks like Bootstrap or any of your favorite 1,000 CSS in JavaScript libraries helping us with the CSS. And that is a lot of abstraction and a lot of magic. And every one of these stages is doing that thing now. It is bridging two different representation. It's kind of twisting one level of representation to represent an adjacent layer, just like SQL Alchemy twists the Python expression to represent the SQL. Well, we're Pythonistas here. What does the PEP20, the Zen of Python, have to say about this? Here's a famous saying from that PEP: simple is better than complex. I mean, look at this system. This is not a simple system. Simple is better than complex. I'm going to call that one a fail. Here's another famous one. If the implementation is hard to explain, it's a bad idea. Just if you're at all familiar with this ecosystem, think of the pages, the reams of digital ink that have been spilled trying to explain why React is doing that thing and how to stop it. This is not something that's full of easy to explain implementations. Perhaps the most famous one of all, there should be one and preferably only one obvious way to do it. Oh boy. So I present to you that the web is incredibly complex, layered with layers of magic that we put on in an attempt to dull the pain of some of the previous layers of magic that we've put in, and is overall highly unPythonic. So we sat down and asked, well, how could we do it better? So if you're looking at a stack like this, an immediate temptation is, of course, to say, well, I get a lot of pain from using React, so let me write a new, better JavaScript framework. And I mean, nobody ever does that, right? There's only ever one JavaScript framework, right? We certainly don't have 30,000 coming out every week, right? I'm getting some news. But that, and as we've seen, that temptation leads us to some unhelpful places, because even if you wrote the world's best JavaScript framework, you still have to understand all of these blue boxes and all of these yellow boxes in order to get anything done at all. And making a better JavaScript framework doesn't change that. You could also do what the Anaconda guys have done with PyScript, which is say, actually, I want to swap out one of these blue objects. So over here, I don't want to be having to represent my client-side objects in a different programming language to my server-side objects, and I totally get why that's why you get the impulse to do that. But the end result is, sure, you have a stack in which you're writing those client-side objects in Python rather than JavaScript. But you still have the same number of blue boxes and you still have the same number of yellow boxes. You haven't actually addressed the underlying problem, which is that there are way too many different representations and you have to spend all of your time converting your data between them with a little bit of sprinkling of business logic and actually doing your job on the side. So we decided, well, what would happen if we took all of this stuff away and replaced it with one abstraction. The abstraction we chose was the Python programming language. And this is the Anvil framework I'm going to be talking to you about today. So what we built is a UI toolkit built in Python. And yes, we also run Python in the browser, in the client side. And that means, but this means that when you're manipulating your user interface, you're not generating HTML DOM, you're manipulating Python objects. Python on the server, of course, but once we've got Python on the server and Python on the client, we don't have to mash all our data through JSON anymore. We can just make a function call. And we even have a Python native database you can use. So that's the idea behind trying to replace this stack of complexity with nothing but Python. Let me show you what it looks like in practice. If you give me a moment to switch to a more helpful camera. All right, hello. So I am going to show you what I mean. So here I am in the Anvil editor, and I am creating a new web application. So over here is a web page, and over here is a toolbox of things I can put onto that web page. So if I want to put a title on my page, I can just take a label component and drag it up here, and then I can change some attributes of it and call it hello world. Fine. Okay. I'm going to be a bit more interactive and show you a little bit more of what this can do. So I'm going to make it prompt the user to enter their name and then greet them by name. So I'm going to put a card on here. I'm going to put a label on here to prompt the user to enter their name. And then I'm going to add a text box so they can answer that question. I'm going to call it name box. Everything in Anvil has a variable name, so you can access it from code. I'm going to add a button here so they can answer that, so they can click when they answer that question. Say hello. We can make it a little bit more prominent. And you can see what's going to happen here. Clearly, they're going to enter their name, click a button, and a message is going to appear greeting them by name. So the final thing we need here is a label for that message to appear on. I'm going to call it message label. I'm going to make it centered. I'm going to make it big, and so on. So I've just built a web page, and obviously that's a bit faster than it would have been with HTML and CSS. But the really cool thing I'm here to talk to you about is that this is all backed by Python. So if I double-click this button, I'm actually editing the Python code that runs when that button gets clicked. And you can see that all the things I dragged and dropped onto my page are actually available as variables in my Python code. So if I want to change the text on the message label based on the text in the name box, I can go self.messagelabel.text equals hello self.namebox.text. That's it. If I run this, if that is how to spell my name, what can I say? We have a working application. So I've just built a web application entirely in Python, and that was pretty fast, I think you'll agree. Now, everything I've done so far is actually running in the web browser. So this Python code is being compiled to JavaScript and is running in the browser when you run the app. We'll talk about how that happens later. But in practice, any serious application is going to need some server-side code as well. So I'm going to add a server module to my application. So this is a Python module that runs on the server. Ordinary Python module, ordinary Python function. Oh, not an ordinary typist. OK, but what we can do is we can tag this function, anvil.server.callable, and say, hey, this function on the server is something I should be able to call from the client. So notice we're not having to set up any HTTP routes. We're not having to like work out how to mash all our data into JSON. We just defined a function, and then we go over here. So when the button is clicked, we anvil.server.call that say hello function. It wants a name, so we give it the text from the name box. And now when I run this, you can see I've got some output in the logs. And now we're really in business, because sure, there's limits to what you can do in a web browser, but this is a proper CPython environment. You can go and do what you like with it. You can import CycleBG2, connect to a database. You can import pandas, do some data processing, import PyTorch, do some machine learning. In practice, the database is the first thing everybody asks for, so let's create a table with Anvil's built-in database. So this is backed by Postgres, so you can chuck gigabytes into this thing if you want to. I'm going to be a little bit less ambitious. I'm just going to record the name of every visitor who signs up and when it was that that name was entered. And that's it. I've built my database. So this table is apptables.visitors, and it's accessible from our server code, just like those text boxes and buttons were accessible from our client code. So if we take apptables.visitors, we can just add a row to it. We fill out the name column with the name that's been passed in. We fill out the when column with datetime.now, which I'm going to have to import. Now, if I run this, I have some data. So if I go back to my database, I can see that data has arrived in the database. So I've just built a web application entirely in Python in a very short period of time, and it's backed by a database. Now, I'm going to want to show you one more thing before I go behind the scenes and show you how some of this stuff all works, and that is displaying some data on the screen. So, so we're going to want to display, let's say, the set of people who have previously entered their names. So what I'm going to do is I'm going to put a card here. I'm going to add a data grid. And then I want to fill this data out with the data from the database. So let's go to our server module and make a function that returns that data. So it's an Anvil server callable function, get visitors, and it returns apptables.visitors.search. And that's just returning an iterator of all rows in that data table as a Python object. So now let's go to the code of our front-end UI. And actually, I'm going to show you a little bit more about the data grid first. So this is a grid. We can have a few columns. So we're going to want a column for the name, pulls out the name column. Going to want a column for when that name was entered, which pulls out the when column. And my mouse wheel has decided not to play ball because I'm on a live stream. And you can see I can adjust some other things here. I can adjust the width and so on. So what I've got in here is I have the data grid, which has these columns, and inside it I have something called a repeating panel. And this is a component that has a property called items. And we can give this any Python iterable object. And what it will do is it will repeat this chunk of user interface once for every element in that list. So if I go into my code, I take the repeating panel, I set its items to, well, the return value of that get visitors function I've already written. So now if I run this, it's displaying the one and only visitor so far in my grid. All right, we're nearly done. I just want to show you one more thing because this is kind of ugly, right? We have this, you can see what's happened here. We've just called stir on a datetime object, which is kind of messy. So let's go and format that. So I'm going to go drill into this template object. In this when column, I am going to, instead of the default, I'm going to put a label here, and then I'm going to add a data binding. So I'm going to say that the text property of this label is set to self.item, which is a row from the visitors table. And I want to use the when column, which is a datetime object, and then let's format it. So stir of time. Now, when I run this, you can see we have some a nicely formatted date. So I've just sprinkled just a little bit of Python in there to change the behavior of my data display. Zooming out here, what I've just done is I've just built a full stack web application entirely in Python, and I'm just going to put it on the web. So let's call it Hello, We Are Developers. If you went to hello-wad.anvil.app right now, you would see this app. It is live. So mouse wheel. I have just built and deployed a Python-backed web application in a very short period of time, and I haven't needed to know any of that horrible stack of technologies I was showing you earlier to get it done. So I hope you enjoyed that. What I'm going to do next is I'm going to take you behind the scenes and tell you a little bit about how the framework I've just been using works. All right. Oh, click it. So, excellent. The first thing to say is that everything I'm talking about here is open source. So if you would like to follow along with the sorts of things I'm talking about, head on over to the GitHub page, or you can pip install it and run this framework locally. So I'm going to be talking about a few things. I'm going to be talking about how you just saw writing Python and then somehow running it in the web browser. I'm going to be talking about how we did these function calls to get data and put data onto the server. I'm going to talk about how I was passing database rows back and forth. And then I'm going to talk about one of my favorite things I built in the Anvil editor, which is the code completion. So let's get started. So we have a problem. We want to write some Python code, and we want to run that Python code in the browser, so we only have to use one language, one abstraction. But a browser only really understands JavaScript. And so we need to somehow translate from one to the other. So what we do here is we use a library called Sculpt, which is an open source Python to JavaScript compiler. So you feed it some string of Python code, and it will produce a string of JavaScript code that does the same thing. You feed it a Python function. It will produce, honestly, the ugliest JavaScript function you have ever seen, but it will actually do what that Python code did. Now, what I'm going to tell you a little bit about just now is a little war story of how we dealt with a problem that was created by JavaScript and produced a slightly smoother user experience. So one of the things about JavaScript is that it is a 100% non-blocking language, which is to say every JavaScript function must actually complete in order for the browser to start operating again. And Python, idiomatically, is quite a blocking language. You really want to be able to write stuff like this. This is an example of kind of APIs you've seen me using. So get some data from a database and then do some computation on it. And this kind of code is kind of natural to write in Python. And sure, there is kind of async, await, and all that stuff, but that's generally regarded as the advanced class. You need to be able to support APIs like this. Now, the problem is that this is how you do that in JavaScript. So even if you're using async awaits, this is what it's translating to under the hood. There's a set of nested callbacks and promise objects representing the half-done things and functions that get called. There's three sort of blocking points here, really, points where you'd want to be waiting for some other piece of code to do something. And if you think I'm being a little bit unfair here in my characterization of JavaScript, I point out I copied and pasted it not that many years ago from the front page of the Postgres JavaScript documentation. This really is what's happening under the hood. But we have a Python to JavaScript compiler. So couldn't we try converting this into this automatically? Well, so we go to GitHub and check out the source and see what we can do. It turns out that Sculpt has a pretty classic compiler architecture based, unsurprisingly, on CPython. So what happens when you compile some Python to JavaScript is that first you take this string of Python code, you divide it up into tokens, sort of little strings that are more meaningful in the context of a Python program, And then you parse that sequence of tokens into something called an abstract syntax tree. And this is a tree of the Python operations that are going on. So here, what we actually have is we have an assignment. On the left-hand side of that assignment is a variable named result. On the right hand is a call of function f with the argument 42. And then once we've assembled this tree, there is a compiler that walks over this tree, spitting out JavaScript. So if we want to make it possible for this function call to block, clearly this is the bit of code we're going to want to modify. And what we did is we implemented a change to how you can represent a function call. We implemented a new return type from the generated JavaScript function called a suspension, which it could return to say, hey, I'm not done, I'm just blocking, and here is my state, resume me later. And so whenever we call a function, we do what you've got over here. So we call the function, and then we check whether we got a suspension back. If we got a suspension, then we, in our currently running Python code, save all our local variables, save all our temporary values, and return our own suspension back to the runtime. So here's how that works in practice. So here, we're clicking a button, we're interacting with the database. And so we've got the Anvil framework calling button one click, calling the get method, going to Postgres, which blocks. And so that returns a suspension. And so the get method saves all its local variables, saves its temporaries, saves where it is in its function, and then returns its own suspension to button one click, which saves its local variables, saves its temporaries, saves where it is, and returns out to the runtime, where it just sits and chills for a few milliseconds until the database comes back. At which point we can resume that suspension, which is kind of another way of calling the button one click function, but saying, actually, don't start from the beginning, start from halfway through, start from this point where you stopped last time. And so that will restore all its local variables, restore all its temporaries, jump to the right point in the function, and then resume its inner suspension, which will restore its locals, temporaries, jump to the right place, and resume the innermost suspension. And that will immediately return. And now we've reinflated our call stack, and we are back to executing normally. So that's a whistle-stop tour of how we turned blocking Python into non-blocking JavaScript so that we could provide nice idiomatic Python APIs for people to use. If you want to know more about this, check out sculpt.org. I am one of the maintainers. I actually did most of the work that I've just been talking about, and we are always looking for new contributors. So do come along and help out. All right, let's talk about the next thing. Function calls. So you saw me doing all this sort of Anvil server.call stuff rather than having to mess with HTTP. Well, how did all that work? Well, we have these calls like this. We've already seen how we can turn like a call like this into a blocking operation. So that result equals bit we kind of get. And then this is just a Python function call. It's got positional arguments and keyword arguments. And what we do is we send this over a remote procedure call system over WebSockets. And we encode those arguments and return values as JSON, which is fine for the sorts of values that you're seeing in this code listing here. But what about non-JSON data? Because in that example, you saw me, for example, returning an iterator over a set of database rows. So we actually implemented an extension called portable classes. So what you can do is in Anvil is you can take any Python class and you can decorate that class, say, hey, this is a portable class. And now any instance of the potato class that you pass over Anvil.server.call to or from the client, you can pass it and it will emerge as an instance of the potato class on the other end. And the default implementation is you take the class's dictionary and you transmit all that data, but you can, of course, customize how exactly one of these things represents itself on the wire by implementing serialized and deserialized methods. And again, this is one of the payoffs of having Python both client and server and not sticking slavishly to the HTTP thing in the middle. It means that you can actually pass your own sensible domain-specific objects around in your code. But that on its own isn't quite enough to do what you saw me doing earlier with those database rows. Because even if database rows are portable classes, and they are, when you pass them to the client and then you call some method on them, get some data out of it, goes back to the server. How do you know whether the client, the browser, this untrusted environment, is allowed to access that data? Well, for this, sorry, a little bit of example here. So we want to be able to take a database row and pass it to the server and return it to the client and act on it. But when we do that get at or lookup on person, that could cause a query to go all the way down to the database. And we need to work out whether that is allowed. And to do that, we provide a capability model, which is a fancy computer science way of saying, if you've got it, you can use it. So the idea here is that every time you return an object or pass an object around, you also pass permission to use that object. So by returning that row from the database, from that server call, I gave the client permission to access it. So the way that this is implemented is that for a capability, there's some kind of identity. So, which row this is in which table, and some kind of permission. So you can read this. And then we take all of that and we construct a digital signature over it. And what that means is that when the client wants to, say, read from this database row and makes a call back into the server, we can check that signature. And if that signature matches, then we must have given them permission over, these permissions over this identity, because otherwise they wouldn't have a digital signature for it. We're the only ones with the key. And here's what that looks like in practice. So you can construct one of these capability objects. You have an array of things. So here it's within the database, this table ID, this row ID, this level of access. And you can then check this in your server call. And this allows us to dynamically implement permissions. So for example, here is a server function that you give it a name, and then it checks whether the user is currently logged in using Anvil's built-in user authentication, which I don't even have time to talk about today, but trust me, it's cool. And then if there is a currently logged in user, then it goes and queries the database and returns the row to the client. And because this is a capability system, we have also passed the permissions to the client at the same time as that object. We don't have to implement like a permission check that's separate from our data check and let the two get out of sync, because that's a classic way of making security holes. We just return the object, and because we have returned that object, the client can access it. We can be a little bit more advanced. So here we are returning we're taking a client writable version of the people table, exactly the same function except for this client writable thing. And what that means is that that object is going to be returned with permissions saying, hey, actually, you can write this from the browser. And now we can get that object, and in the web browser, we can update it. And suddenly, you can write your database update logic in your UI, in your button event handlers. And we have stripped out all of that plumbing to get that operation all the way from the browser to the database. You can just update it right where you are. Of course, it's not just objects, not just rows that are portable objects. You can return whole views. So let's imagine that we have this table of records, and I want to allow the client to access only the records that are owned by the currently logged in user. So you've got this name column, this age column, this owner column, which is a link to a row from the user's table. So I want only some columns or some rows from this table. What I can do is a function like this. So this is a function that gets all my records. So we get the currently logged in user, and then we check whether they're logged in. And then if they are, we take app_tables.records, we get a client writable view, but with the constraint that the owner column must be the logged in user. So the result, you can pass it back. It's a portable object. Is you've got something that quacks like a table. You can add rows, you can query it, you can update it, and you can push more and more of that work into the client-side code securely because of the capability architecture. All right. Finally, I would like, before we wrap up, I would like to talk a little bit about one of my favorite pieces of Anvil, which is code completion. So auto-completion it's that little pop-up box you see in any programming text editor that's offering to complete your variables, your identifiers, and so on. And it's genuinely awesome. It's an essential part of any modern development environment. It gives you discoverability. It gives you the ability to find out what methods are on object without paging over to the documentation. It gives you speed because you can just hit IN tab instead of spelling initialization correctly for the 5th time this function. It gives you confidence that what you're doing is right because there are whole classes of mistakes that code completers will let you discover and fix without even hitting the run button because it's warned you, hey, the world is not quite as you seem. And for all those reasons, it feels good to use. Now, there are, in fact, off-the-shelf code completion systems like Jedi already available. Here it is being used as a plugin in Vim. But we had some constraints that made it rather difficult to use an off-the-shelf thing. For one thing, Anvil's a full-stack framework, you may have noticed. So the code completer needs to know about the database structure and about what's in your server-side code and about what widgets are in your client-side user interface. And fine, we probably could have hacked that information into Jedi. But the real bummer is that this is a web-based editor you saw me using, which means that there's not a lot of time between keystrokes to go back to the server, send all our code back to the server, run it through some code completion engine that's expecting files on disk, and then send it back to the client. If you've ever used a system like this, I won't name names, but that's like steering a wonky shopping trolley. It's awful. So we ended up building our own in JavaScript, which sounds like a really daunting task, except you remember we already have a Python to JavaScript compiler sitting there running in our browser, Sculpt. And I've already talked to you about how the front-end parser works. So what actually happens is that when you see me hit the tab key in the Anvil editor, what happens is we take that code, we replace the cursor with a magic symbol, and then we feed it to the parser and get out one of these abstract syntax trees. And we can walk over that tree. And we can say, oh, hey, we're in a button one-click function. There's an argument called self and event args. I guess those are local variables now. There's an assignment to a variable named x. Well, I guess that variable exists now. Here's a function call. What's the argument? Oh, it's the cursor. Well, now I've built up this representation of what's going on. I can offer, hey, here are all the local variables that exist in my code. Of course, we're not restricted to completing local variables. Once you've got this idea of sort of walking over AST and building up a representation of what it's doing, you can do some quite complicated things. So here we are taking at tables, taking the user's attribute of that, taking the search attribute of that, calling it, looking at its return value, iterating over it, then taking the square bracket get item lookup on that. But as long as we keep track of the types of what everything is, we can actually offer contextual assistance on, in this case, bits of our database. Speaking of context, this also enables us, again, this is yet another dividend of doing both client and server in Python. We can do code completion between client and server, which is normally a real pain. So here we're calling this say hello function, and we would like to be able to autocomplete across that boundary. So we say, oh, hey, I'm calling the server function called say hello. Here's its argument types. Better remember that for later. And then later, when you go and edit that server function, as we're walking into this function, we can go, oh, this is the say hello server function. I know what arguments this is called with, and you can stick those into the local scope where they can autocomplete. So there's an awful lot of information that you can know about your program, your functions, the types of your variables, if everything is in one language and with a coherent sort of function calling convention. Speaking of types, you can end up in some fairly philosophical discussions about what exactly a type is. Now, as Python developers, someone up there is holding their hand up going, oh, pick me, saying, well, I know what a type is. There's a function called type. You give it an object that tells you its type. Well, sort of. It gives you its class in Python, but that's not always the whole story. Take these two dict objects. These are two separate dictionaries. They are both instances of the dict class. Their type, in the Python sense, type brackets object, is the same, but they have different keys. And as you've seen from the database example, it's kind of in our interest to be able to treat those differently. So what we've said is kind of forget the Python classes. We duck type the code completer. As far as we're concerned, these two objects have two different types. And so we track them separately and we can offer nice code completion. So your code completer is allowed to know more than the Python interpreter. Okay, so I have taken you through a little bit of the motivation of Anvil. I've taken you through a whistle-stop tour of some of the things that Anvil does. And I would like to finally finish up by talking a little bit about the design philosophy underlying everything you have seen today. And there are two big principles I want to talk about. The first is that code is good. We are telling a computer what to do. We've been telling computers what to do for about 3/4 of a century by now. And in all of that time, nobody has come up with a better way to do that than code in a vaguely algebraic programming language. Now, periodically, someone will come along and look at that stack of horror that I showed you at the beginning of this presentation, hold their head in their hands and go, "Oh my goodness, this is terrible. Let's make a way where you can build these applications without having to write any code, without having to get your hands dirty." And this is almost always a false promise, because it's going to have some way of telling the computer what to do that's less powerful. And so you're going to end up eventually with either Cthulhu's own flowchart, or simply not be able to do what you want to do that the computer can do, but if you're operating with some Fisher-Price simplified model, you can't tell it what you want it to do, and you'll find yourself throwing your monitor out the window and saying, "Just let me write the blasted for loop." The problem with the web development isn't the development, it's the web. Take the web complexity away and then get me to the code. Code is good. Even in that user interface designer, you saw when I was changing how to display that date, I wasn't dragging and dropping some kind of noodle from the database onto that data grade editor. No, I dropped down and I wrote some Python code. And because I was writing Python code, I could pull in the standard library. And when I wanted to format that date, I had access to all of date time and stirref time, because it didn't try to get in the way between my fingertips and that power. Code is good, get me to the code. And the second really important principle I want to talk about is accessibility, because the web is horrendously inaccessible. Now, if I went and snap polled people in this audience about what accessibility means in a programming system, I would probably get some kind of answer like, well, if it's accessible, that means it's simple enough for novices. And you're right. I mean, the web is unforgivably hostile to someone trying to learn it. And yes, we need to fix it. Yes, novices should have an easier time using the global application development platform. Absolutely, no question. But it can't only be that. If you create something that's designed only to be simple enough for novices, then you're going to do a tremendous disservice to two groups of people. First, you're doing a disservice to the novices, because if you stick them in the playpen, they have no room to grow their powers. Yesterday's novice is today's intermediate, is tomorrow's advanced developer, and you need to give them a space to grow. You need to give them real power. And the second group of people you're shortchanging are the seasoned professionals. Because just because I can write 5 programming languages and 6 different frameworks in order to get my job done doesn't mean I want to. It doesn't mean my manager or my customers want to wait for me to do it either. And so to be truly accessible, if you want to solve these problems, you need to be simple enough for novices and powerful enough for seasoned professionals. And sure, I can't see any of you, and yet I can already feel the eye rolls. Because we've been conditioned, largely by the web, actually, we've been conditioned to think that it is impossible to do both of these things at the same time. You can't be simple enough for novices and powerful enough for seasoned developers. Can't be done. But we, as a community, ought to know better than that. Because if you look at your text editor, if you're here, you're probably writing Python. Python, the language that's the first thing you give an 8-year-old child sitting down with their first Raspberry Pi, going to make something go beep and a light go on. And Python, the language that powers Instagram, the thing that powers every modern piece of data science, every new AI advance that makes our head spin. It is possible to be simple enough for novices and powerful enough for seasoned professionals. We have the proof literally in our own hands, and it is only the garbage fire of modern web development that ever makes us doubt it. Thank you very much. All right.
Hey, Meredith. Welcome
Hi,
back to
Benedict.
Live Stage. So, thanks for that insight on Anvil. It was
Thank you.
very fascinating. And we got a couple of questions. So, you ready for a short
Sure.
Q&A? Perfect.
Let's do it.
So, first one from David, who wants to know, can you please explain security in Anvil? For example, when it comes to SQL injections.
So SQL injections are a perfect example of a vulnerability that only exists because that horrible stack of code, right? SQL injections happen because the only way to get something done is to generate code in a different programming language using user input. I mean, who ordered that? And you've seen, actually, I think probably since you wrote this question, you've probably seen how this works, which is that because you're not generating HTML source code from your Python code, you're using a Python UI toolkit, you don't have cross-site scripting. Because you're not generating SQL code from your Python code, you're using this data tables API instead, which is a Python object-shaped API. Hey, what do you know? There isn't actually a space for SQL injection. So there's this general rule of thumb that number of bugs per 100 lines of code is roughly constant no matter what you're doing. And so actually simpler is more secure, because by stopping users from having to deal with all of this complexity, you also let them avoid the bear traps involved. So the answer to SQL injection is we don't, because you don't need to do particular protection, because if you actually give people an API that makes more sense, that space isn't really available.
Thank you, Meredith, for that insight. We got a couple of more questions. For
Sure.
example, Mr. or Mrs. Anonym wants to know, how do we use Anvil for custom functionalities, for example, calling API or scraping web page?
So, I mean, scraping web pages, you want to use Scrapey, right? Or Beautiful Soup. Well, that's fine. That's Python. That's a Python library. You just import the Python library and do the Python thing. I mean, there's a colleague of mine wrote up a whole series as a how to build a search engine series that involves scraping and crawling pages and indexing. But the actual how to scrape web pages, you import the Python library. Hitting an API, likewise, import requests. It's just Python. The point about get me to the code is you get you to a real programming language with a real ecosystem. And the answer to just about any of these questions is you do what you do in Python. And yes, of course, you can hit APIs from the front end as well as the back end. And yes, of course, you can create API endpoints rather than, as well as just Anvil.server.callable functions. You have all that ability. There's a whole other talk I gave at Python WebConf last year actually about this. We believe quite strongly in escape hatches. You don't keep people sealed inside a tool like this, because Anvil is never going to be bigger than the web, right? There's always going to be more things you want that are on the web, complexity you might want to be able to interact with. So you can't say, oh, well, you can never leave this box. But equally, if you do some kind of code generation or whatever, then you spat out a Django app, well, that will be unhelpful, because the moment you hit that button, you can never edit it in Anvil again. So the idea is lots of escape hatches, something you can climb out of in a dignified manner, do what you need to do, climb back in. And REST APIs are merely one of many, many, many other examples. The other classic one is JavaScript interop. And of course, there is, you can define, you can import a JavaScript library into Anvil, and then from anvil.js.window import the library and drive those JavaScript objects from Python. You can absolutely do it. Then you can encapsulate it all up in a Python class, in a reusable component you can make as a dependency other people can import, and you are the only one who had to get your hands dirty with JavaScript. So yes, escape hatches, we're big on them.
Okay, perfect. Then next question from David again. Can we use there even more complex queries, subqueries, etc.?
So yeah, this is the trade-off involved in data tables. So the broad answer is that the expectation with Anvil's built-in data tables is that you will do that in Python. So the idea is we try to make it pretty performant to pull back these amounts of data. And if you want to do some complicated subquery, you do it with Anvil. You do it with Python. There's obviously quite a bit more querying functionality than the demos I was showing in today's talk. But if you you can hit the edges of that. And I actually, of all of those yellow boxes, those translation layers, I have the most sympathy for the one that says actually querying a database is a thing that might deserve a specialized language. No judgment. Anvil will not make it difficult for you to interact with, a Postgres. If you want to just pull in a ordinary SQL database like you're used to, and you want to do your 40-line SQL query in that, go ahead, use the standard Python tools. That's what they're there for. The data tables API is deliberately Python object shaped, so you can't do some of the SQL shaped things with it. But in exchange for that, you get, hey, these things are Python objects, and we can treat them like Python objects, and we can pass them freely around our code. So that is a trade-off you might want to make.
All right. So right to the next question from another, or maybe the same Mr. or Mrs. Anonymous. If Anvil is only for backend data manipulation, is it better than Django, as Django automatically provides CROD for admin interface?
Yeah, absolutely. Well, I think the answer is that it is not just for backend data manipulation. That is sort of the point. The point is that you can write that front-end code. And sure, something like, building CRUD applications, an awful lot of the world's programming is CRUD applications, sure, and Anvil get used for that, sure. But it absolutely does get used in, consumer web applications. Reject the premise of your question. It is not just for backend data manipulation. But even if it were, even if you're just taking backend data manipulation, unless you are using what Django generates out of the box, without any changes, and you saw how fast I built that application, you'll probably still get there faster with Anvil than you will with Django. That's no knock on Django. It's that Django can only solve the problems of kind of the bottom two boxes on that stack, which is, it helps you with the database, helps you with the Python, helps you with the REST framework. You're still going to have to build some front-end interface if you want to do anything different to exactly what comes out of the box.
Okay. Thanks for clarifying that. We got another question from David.
Hello again, David. I should make a point that my email address was at the bottom of that last slide. So if we run out of time, you still want to talk to me, you can email me. But go ahead, hit me with the question.
I think you just met a friend. So, David, it's more a general question, but I think it's quite interesting because he wants to know: do you think that Python will be #1 programming language in the future?
So, I'm very bad with a crystal ball. So I should really be wary about breaking out my second sight on this one. Python, I really love the phrase, Python is the second best language for everything. And I think that as long as that remains true, it has a bright future ahead of it. I think that the complexity of the web is one of those things that could knock it over. Because if just by sheer force of habit, everybody has to get used to basically a JavaScript-derived language, then people will start writing more and more stuff in the JavaScript-derived languages. I'm not going to lie here. I don't have a huge dog in this fight. I believe in Python's values more than Python the language. The values of simplicity, the values of clarity, of accessibility are really important. And so that's why we chose Python as the language for Anvil. I want to see those values continue. And currently, I do think that Python is the best standard bearer for those. And so I am rooting for Python on that basis. But to do that, Python really does have to be the most accessible way to do the important things. And the web is currently an area where I'm afraid to say it is still kind of failing. It's a great way to build a backend with something like Django or Flask, but you still, it doesn't save people from all of that front-end complexity they have to drag in that Python really can't help you with unless you build some kind of Python front-end framework, which is what we were aiming to do.
Some really good points to a not that easy to answer question. Thank you. Next one from Refarius. First, great idea. Have you measured the impact in performance versus traditional software architecture?
That is traditional software architecture is a very difficult thing to quantify and say that you've done a fair test with. I assume you're talking about runtime performance as opposed to build performance. One of the interesting things we found is that Sculpt, the Python JavaScript compiler, Python run with that under some circumstances actually outperforms CPython because you get the overhead of, yes, I mean, I said that it generates the ugliest JavaScript functions in the world because it's having to preserve these Python semantics. And, Python objects have to act like Python objects, not JavaScript objects. But what then happens is you feed it into into a virtual machine with amazing JIT compilers and some of the best teams in the world making it fast, and so actually it can run at really quite a clip. So actually we're not losing as much front-end performance as you might think. In terms of sort of traditional architecture, versus HTTP, I mean, it's fundamentally passing data back and forth. It's it is what it is. I think the development, performance is going to be close enough that I really don't think that's what limits you. I think that it is much more for most applications in the world. As long as you can get to the high level of performance, the real question is how long did it take you to build it? And so that's kind of the thing we were focusing on. But yes, it turns out that on the way the performance is remarkably good.
All right, great to hear that. So we got another question from Angelo, who wants to know, I didn't get how we could impose authentication and authorization for web page users on Anvil.
Yes, absolutely. That's because this was only a 45-minute talk. The thing to Google is Anvil Users Service. So Anvil does, in fact, have a built-in authentication system, which is another example of, by the way, of those things where A, it's a real pain, so it's great to take that off people's shoulders. But B, if you take that off people's shoulders, then you take away, all the foot guns that you can do when doing password authentication. You're going to hash your passwords correctly if you use something off the shelf that does that for you. But yes, the answer is that Anvil has a built-in user authentication system, stores users obviously as rows within an Anvil database data table because, of course, and yeah, it has an out-of-the-box mode where you can just sort of check, hey, I would like, I want email and password, and I want Google SSO, and I want SAML, and I want, email magic link login, and you say, throw me up a login form, and it will do the right thing. But of course, it's a library. You can break it down and do those things all individually. So yes, there is out-of-the-box authentication support. That's really quite flexible and powerful. I can't recapitulate the whole introduction to the user service tutorial by waving my arms without a visual aid, but I'd encourage you to go Google it. Hit the Anvil documentation, just search for multi-user or user authentication or users.
All right, so not that hard to look up actually. Thanks for the answer. So another question from Alex. Does Anvil provide automatic testing? Example, unit integration tests, UI behavior checks, things like that?
This is a public stream. Can I say watch this space?
All right. Then we come maybe to our last question, another very general question from Alda, who says, I'm auto-detecting. I'm a beginner. Which is the best path to take for learning from the best?
Ooh.
Obviously referring to you, Meredith.
Well, I mean, I'm glad you think that. So I would say, I mean, if you're interested in learning Anvil, we have a bunch of tutorials. I would suggest sort of having some basic fluency with Python first. I think we don't have, if you go to our website, we don't have Anvil from scratch sort of tutorials. But if you are familiar with sort of the basics of Python, your conditionals, your objects, got as far as classes, then even from a fairly early beginner, you should be able to pick up Anvil just fine. So I think don't be afraid of it. Go try a tutorial. There's tons of like the step-by-step tutorials and videos and so on you can try. So if you want to learn Anvil, like get a bit of Python first. If you finished your Python book, head on over to anvil.works and see what the tutorials can do. If you're asking me about general developer education, then honestly, I think, A, you're in the right place. You can ask people much more expert than me here, and B, you're in the right place in that you've chosen Python, which is an excellent beginner's language. If you're just at the very beginning steps, then grab a good Python book. I really quite like Al Swiggert's Automate the Boring Stuff, or keep working through whatever you're working through. Just like keep writing code. There's nothing for your code like writing code.
But Meredith, thank you so much for all the insights you gave us today. Hope you have a nice rest of the day and see you soon. Bye.
Thank you very much for having me. It's been great. See you later.
Later. All right, and we jump right to the next speaker of the day, a senior software developer and mentor of PyLadies Vienna. Welcome, Fabian.
Hello, everyone.
Hello, Fabian. How are you doing?
Doing great.
Perfect.
So
Happy to
Anvil looks like a really great solution for web applications. I'm really excited about that.
Perfect. So you already got your key takeaway from the day.
Yes, I did.
So, but Fabian, let's look into your talk. What are we going to learn from you today?
So since I'm a PyLadies mentor, I like to teach the basic stuff. Today is not really basic. It is shipped with every Python installation, which is threads, processes, and other forms of concurrency. I think it is a very important topic because we want to make the best out of our very modern hardware. So this is what I'm going to talk about.
All right, looking very much forward to it. Stage is all yours.
Thanks a lot. So concurrency in Python. First, a little bit, you heard already a little bit about me. I'm a senior software engineer at a company UX. I've been there for almost 15 years now. I've been developing in Python for more than 15 years now. And I really love to talk about Python and to teach Python, also in PyLadies. But you will hear about PyLadies right after my talk. You can reach me via email. You can reach me on Twitter or on GitHub, wherever you prefer. And I'm a quick introduction, quick agenda on what we're going to talk about. So first I have to bore you a little bit with some terms and definitions. I'll try to keep it short, then we get to the juicy stuff. Then we are going to talk about why we want to multitask and in what situation we actually might prefer not to. We're going to talk about threads and processes, and we are also going to talk about a new form of, not new anymore, but another form of concurrency, which is asynchronous Python. So you may have heard that each and every one of us carries more computing power in our pockets with our smartphones or whatever than the Apollo guidance computer had. So the Apollo guidance computer was basically the thing that landed people on the moon. So whenever you lose your phone, there is another place now where you can look. Just kidding. There is this law called Moore's law. So it's not a law in the traditional sense, but it's basically a law that states that every 2 years, the number of transistors per square millimeter doubles. And you can see it here on the chart. So which starts from 1970, and it has been more or less true for the past 50 years, which is just amazing. So we can roughly say that every 2 years we have basically the same, the double computing power in our devices. But there have been recent changes. So in the past, I would say 10 to 15 years, this computing power was not just in the CPUs where it's like made each CPU core faster, but it was basically spent in multiple CPU cores. So the CPU is split into several cores, which do the bulk of the work. But now they're split into multiple cores, so we need more advanced Python or advanced programming skills and programming techniques to actually make use of them. So first, I'd like to talk a little bit about some terms. So first we have concurrency and we have parallelism. But what do they actually mean? So concurrent means that there are two tasks. I signify them in the grid task A, which is green, and the task B, which is red. So they're running in overlapping time periods. So they're basically running at the same time, but they're running in overlapping time periods. So one task, then the other task, then the first task again, and so on. But this is concurrent because both tasks are worked on at a certain period. But this is not truly parallel. Parallel means when each task is actually run on literally the same time instant. And we can actually do this when we're using the CPU cores, when we're doing this by, for example, using threads or processes. So there's also some two important things, which is the cooperative multitasking and the preemptive multitasking. Cooperative means that each task itself decides when it's a good time to give up control. Preemptive multitasking, on the other hand, there is an outside entity, we call it a scheduler. Usually it's the operating system itself, which decides which task is now the next one to be worked on and how long and so on. And it also means that the scheduler needs to make makes context switches. So it needs to switch the whole context of one thread to the next one. And this is a process that takes a little bit of time and overhead. So first we have to ask ourselves, why do you actually want better performance by using multitasking? So one thing would be that we actually have to, because we have performance requirements. So for example, we have the requirement that we have to run a certain task in a certain amount of time. Usually this, so for example, for a web application, this translates to how many clients can our service actually serve without giving up. Another thing could be that we want to reduce our costs. So for example, we have a server rented somewhere, and when we are using all of its capabilities, we can basically do our task faster, so we reduce the cost. And multi-core CPUs are the norm now, so it would be a tough luck for you if you want to find a single core CPU anywhere outside. So we want to be more efficient in order to reduce cost. But there are also good reasons to why not do multitasking. First off, it is way more complex because you have to deal with synchronization between your separate tasks. And also, the tasks are now non-deterministic because usually you cannot really decide which tasks get worked on first and last, and there might be some fluctuations. And might be some bugs introduced which are really hard to track down because they don't happen all the time. They just happen in very specific conditions. And these conditions are really hard to actually reproduce. Also, there is overhead. So this is not also overhead in running the program, but there's also overhead in writing the code because the code is more complex. You have to keep more things in mind, and you have to deal with more things at the same time. So it's more complex in both running the code and actually writing the code and also communicating about the code. And then there's another law, which is called Anvil's law, which basically decides how much speed up do you actually gain when you're introducing multiple threads of your code. So you can see it on the graph on the right-hand side. There's some examples. So the blue line would be that your parallel portion of the program is 50%. So that this is the amount of code that you can actually parallelize. And you can see that it's basically leveling out at twice the speed up. Even if you're shoving more CPU cores at it, you will never get a speed up more than twice of it. If you increase the amount of, or if you manage to make the parallel portion of your program bigger, then you can get a better performance improvement when you're using multiple CPU cores. But you can also see that this at some points levels out, and you will never get more efficient than this. Okay, so then we also have to think about how can we actually do multitasking. And usually there's the two concepts called processes and threads. They're very similar in a way, but they're also different in a way. This is also depending on the operating system, actually. So this is handled differently on a Windows machine than it would be on a Mac machine. But these concepts are broadly enough for the same on all architectures. So processes are isolated. So each process has its own memory layout. They're managed by the operating system. And the way to get more processes is by actually forking. Forking is a process where you take the parent process, apply a fork, which basically is a copy of the whole process and all of its resources. And then you have the parent process and the child process, and both can now independently work from each other. So this is a bit heavy-handed because it involves copying everything inside of the parent process to create this new child process. Threads, on the other hand, are way more lightweight. There is always one process, always one thread associated with the process, which is usually called the main thread. And this main thread can create other threads. And the program itself must declare them. The program itself must manage them. And you can basically create new threads and run them at your will. And you also need to take care of cleaning up afterwards. So how are in Python processes and threads? What are the advantages and the disadvantages? So threads have very, very low overhead. So they can be created quite easily. They don't require much memory or time. And it's also easier to communicate between two threads because the threads actually share the same variables, they share the same memory and everything. You have to make sure that you synchronize this access to this memory, and if you don't want to have bad things happen to you, but we will get to that part soon. And there's also something which is called the GIL, which I'll also talk about later on. Processes, on the other hand, have the advantage that they're isolated. So there's no global interpreter lock, no GIL, which gets in your way. But you have a high creation overhead because I already said that the whole process must be duplicated. So you must be copied to a new one, which makes overhead both in memory and also in time. Additionally, since processes are isolated, you have to come up with your own ways of communicating between those processes because the variables are not shared by each other because they are actually living in a separate memory spaces. So it's harder to send some value back and forth between your processes. So how would you actually create a process or a thread in Python? And Python is really great because there's an abstraction layer, which basically allows you to create a thread very much the same way as it allows you to create a process. First thing is always to import it. On the left-hand side, we have the example with the thread. We import it from threading, the thread class. Then we declare our function that we want to run in our thread. Then we specify the thread and specify the target. And then we have the thread.start and thread.join. In between this thread.start and thread.join, you basically have now two threads of execution. The one main thread, where you can simply work on other tasks in the meantime, and the thread that you run with the thread function. So you basically have now two lanes in your program, and you can do two things at the same time, which is obviously what we want. In multiprocessing process on the right-hand side, it is looking very much the same way, but underneath it creates a process instead of a thread. Since this is very heavy-handed, so you have to create your threads like these objects and so on, and then you have to specify the function and pass it on. This is a little bit clunky because you have to also deal with setting up and tearing down. So there's also easier way to deal with threads. Usually what we want to do is we want to perform the same task, but with different kinds of data. So for example, we want to calculate the factorial of a specific number. And we want to calculate this factorial on specific number or on a range of numbers. So this is the variable called my numbers. We say from 0 to 25, and we want to calculate the factorial of all these numbers. For this, we are using the concept called executor. This is both in concurrent.futures, there's the thread pool executor, and there's also the process pool executor. And they allow you to apply the different values on the same executor, on the same function. So you pass in so you specify executor.map, pass in the function that you want to apply all your numbers on, and then you get the results back. So you basically applied the same function on multiple data. And this takes care of setting up the threads, using the threads and tearing them down, and also collecting the results. So this makes it really easy to apply the same function on multiple data sets. One thing about multi-threading, I hinted at it, multi-threading can be really hard. There are some issues that only arise in multi-threaded programs. I really love the picture on the right-hand side. It's a little bit small, but it says basically, you must be this tall to write multi-threaded code. So this is, I think, from a Mozilla developer, and it's actually a tall guy, and he's actually on a standing desk. So you see how big you actually must be to write threads in an actual software. No, just kidding. So this is, in Python, it's actually easy, but you have to be aware of the risks. So again, you have the green thread and you have the red thread. And what they do is they access the same memory, so the same variable at the same time. So they both read the value 1 out of it. And now they're doing some work. So for example, they're calculating something, and then they increment this value, and the green thread increments it from 1 to 2, and then writes it back to the variable which is shared with the other thread. At the same time, the red thread also read the 1 out of this variable, also incremented it, and also write back the same value. But this is now wrong because we actually wanted to increment it twice. So we came to a wrong result because both threads ran at the same time, and this is called the race condition. So they both raced to read and both raced to write, and actually have overridden the result of the respective other thread. So this is how it would look like in a code example. So again, we have some function. We have a shared value. And in this function, we basically just increment this value by 1. And we are simulating some work by just calling this function sleep. So we basically yield for a minuscule amount of time, then we write back the actual value to the shared memory location. And when you run this, you see that when you print out the actual value, it gives you a different result every time. And the difference can be really substantial. So this is like 10,000 times 4. So the correct answer would be 40,000. But when I was trying this out for this presentation, I was off by like tens of thousands. So this is like a really, really big amount that you can miss because all the threads are constantly overriding each other's results. So how do we actually overcome this? We are using something called a mutex or a lock. Now, each thread is not actually reading the value directly, but each thread tries to acquire the lock, which is signified as this blue line. This is a first come, first serve operation. So the green thread is slightly faster, so it achieves to acquire the lock. And the red thread is blocked. So the red thread cannot advance until it has achieved to acquire the lock. So now the green thread has full reign, and it can actually read the value, it can increment it and can write it back. And then it has to remember to actually release the lock in order for the other thread to pick up the work again. Now the other thread is working, it acquires the lock, then it reads the value, which is already incremented, and increments it again. And now we finally get to the actual result, which is 3. In Python code, this looks very similar to the first example. You now have to use the threading lock, which we create in the top of the code example. And you can see in the function now, we are simply saying with lock. So this is a context guard, and inside of this context guard, we acquire the lock. Then we're doing our calculation, which can result in a race condition, and then we release the lock again. So you don't have to fiddle around with the lock, and it's automatically cleaned up afterwards. And then with that, it's easy because you always get to the right result. There is also another lock that you are always dealing with, even if you know it or not, which is called the global interpreter lock. So Python has it built in, and it's basically prohibiting race conditions inside of the Python interpreter, which is very important because Python uses increments and decrements all the time to count how many references there are for an object. So when an object has a reference count of 1, it is alive, or if it's 1 or more, it is alive. But if it's 0, it can be cleaned up by the interpreter. So there's constantly incrementing and decrementing of these values. So it needs some sort of synchronization, and this is the global interpreter lock. But this also means that only one thread at a time can actually interact with the interpreter. So only one thread at a time can actually run Python code. This is mostly true, but there are some automatic ways where this global interpreter lock is actually released. So for example, if you read from a file, inside of the file.read function, the global interpreter lock is actually released for a short time, and then it is reacquired when we have the result back. But also, the global interpreter lock is periodically released in order to allow multi-threading, to allow also other threads to advance in their task. The global interpreter lock can reduce performance quite significantly, but you always need to test your code, and you also always need to make benchmarks when your process is actually impacted by this. So if you're dealing with a lot of I/O, it might not actually be that impactful. But if you're dealing with a lot of computations in Python, it might be very impactful. And in the extreme case, you might only get single thread performance, even if you're using multiple threads. Okay. Threads and processes are a good way to achieve concurrency, but they also come with a cost. So each thread has its own stack, each thread has its own memory that it requires, and processes even require more memory than threads. There's a lot of administrative overhead, which is basically the context switches from one thread to the other. And also the cleanup times and the setup times of processes and threads are actually quite substantial. Also, there is a limit in how many threads and processes you can actually create. So the operating system might say, okay, we cannot support more than that many amount of threads or processes. So at some point you will be the operating system will say you cannot create any more threads or processes. In 1999, when we remember back, this was basically the advent of the internet. Very smart people considered this the C10K problem, which stands for 10,000 concurrent clients. So it means like 10,000 concurrent clients were requesting resources on a server, and the server had to make 10,000 threads or processes in order to serve all of the clients. So it was obvious that this was not the way to go, since each process and thread actually introduced that amount of overhead. So it was not possible to do a one-to-one mapping of one client to one process or thread. In order to circumvent this, they thought about this very hard, and they came up with this event-driven programming style. And this basically turns the whole thing around. So there's now not one thread per client, but actually it's there are event handlers inside of the operating system when it tells you, okay, now you can read from a file, now you receive some data from the internet or something. So for all of these events, a handler is installed, and each handler is associated with a coroutine. A coroutine is something very small, something basically, it's not a thread, it's based on something very lightweight. And in order to write code that is very familiar with only slight changes, they came up with the term asynchronous programming. And this turns out is actually a great way to do asynchronous programming with Python, because it basically means that your program looks very much the same. There's only some minor syntactic changes involved. Again, we have to define some terms. So a coroutine is basically a function that can be suspended and resumed at a later time. You also need some sort of event loop. This is the thing that's listening for operating system events. And it then schedules and runs the actual coroutines or the asynchronous tasks. And there's also the concept of a future, which says that, sorry. A future is basically a value of something that will arrive later on. This says this is a future. So this is a value that will be arriving at a later time, and this is also known as promises in other programming languages. Okay, so how does asynchronous programming in Python look like? So it uses the new keywords async and await, and you can declare a synchronous function using the async def syntax. And inside of asynchronous functions, you can await on values of futures. So you can say, okay, now I run some function and I get back a future which results in a result at a later time. And I can await this future to get the actual result back. So on the left-hand side, you see the traditional way of programming. You see I just call a function which gives me the result directly. But on the right-hand side, I don't get the result immediately, but at some point I will get the result. And then I can say myself, now I want to await that future and want to actually get back the value out of it. Await is only valid, so it's syntactically only valid inside of an asynchronous function. But if you think about it, this means that everything must be actually written in an asynchronous way. So because you cannot simply await outside of an asynchronous function, how does it actually work? For this, you need a so-called a runtime. And the good thing is that Python comes with an asynchronous runtime already built in, which is called async.io. So you can simply import it using import async.io. Then you declare your asynchronous function, just as before. And then you need to get the event loop. So async.io simply creates you an event loop if there is none existing yet. Then you simply call your function, your asynchronous function. What you get back is a coroutine. So a coroutine is basically something that says, okay, I'm currently working, but a coroutine must be driven. It must be driven, for example, by the loop. So you simply pass it on to the loop and you say simply run until complete. And this is how the whole asynchronous functions get initialized. There's some important things. Asynchronous functions are run by the event loop, but they require actually sequence points. So these are the points where we actually await a value. And if you are running long, so if you're calling long functions that will block for a longer time, this will mean that the whole event loop is simply blocked by this one task. So this will also prevent other tasks to be run. There are ways to circumvent this. So usually there's, for example, there's an asynchronous version of a synchronous function. So for example, there's the time.sleep, which basically means, okay, this task is now sleeping for that amount of time. But in async.io, there is an asynchronous function instead. So this means that it does not block the whole event loop, but it works well with the whole async environment. If you have a long-running blocking function, you can also pass it on to the running executor. So this is also provided by async IO. So you simply pass it on to another thread, and then it runs there. And yes, you're basically freed with your async function again. This is now async. This is now asynchronous, but it's basically just the same way as we programmed before. But how do we actually achieve concurrency now? This is also quite easy. There's 2 ways to do it. So one would be to create the loop again. You get the event loop again as before. And now you simply say, okay, I want to create now multiple tasks and run the multiple tasks in the side of the event loop. And basically, each one is now running independently, so they run concurrently. This is a little bit clunky. It's easier with the async io.gather function. The async io.gather function collects multiple coroutines, and it will return when all of them have actually concluded. So you can fan out to multiple paths of multiple paths of your program, and then collect all the results. And all of these tasks have been run concurrently. How would you use async IO in practice? So for example, there is the web framework called Starlet. So this is a very popular web framework which powers, for example, Fast API, which allows you to write an HTTP server that makes use of asynchronous IO. So you have all the benefits of, for example, dealing with many clients. And you can simply specify your asynchronous. You can specify your asynchronous view function that will handle the request. You can then use await if you're doing web requests or reading from a database and so on, and return the result as usual. So with Starlet, you are able to serve many clients, many more than you would be able to with, for example, a framework like Flask, which uses synchronous code underneath. Okay, I know this is quite much. I'd like to thank you for your attention, and I would like to ask you for any questions. Quick note, all the images of these 2 guys are from a kid's book called Die Gaggis. So this is a very old book. I know it from my childhood already, and I now read it to my kids. It's a great book teaching about concurrency, because there's basically 2 stories which are first separated, then they intertwine again, then they separate, and then they merge again together, which is a nice analogy. And it's also a good book against racism. So it's perfect overall. Okay, I'm open for questions.
Fabian, welcome back on live stage. Thanks for the awesome talk.
Thank you.
Hope you enjoyed it as well. We got one question submitted from David again.
Mm-hmm.
He wants to know, many say that Python is slow, but it is the easiest. What do you think?
I think this is true. So Python can be slow, but it can be very efficient if you want to actually do some work with it. So I've never seen a language where you can achieve your goals in that amount of time. Python in execution can be slow because it is interpreted, but there are ways to make it really fast. And one of the ways is to actually know when you are dealing with, for example, a global interpreter log. So you can work around the limitations of Python, and you can do some really great things with Python, even if it is considered a slow language.
Okay, thanks for clarifying. We got another question. How do we choose a right number of threads processes?
This is always a tricky question, but the best way is to benchmark. So you have like your initial solution, and then you say, okay, I need to benchmark now, and I need to figure out the right amount of threads and process. It's really hard to determine because there's many different resources that are attached to your program. So this can be memory, this can be input and output, this can be, for example, web resources and so on. And you must first determine where your program is actually bound. So what are the actual limitations of your program? And then you can choose if you're using threads or processes instead, and how many you actually need.
All right. Fabian, thank you for the insights you gave us. You are mentoring at the PyLadies Vienna, and actually the last speaker of today, Tina, is organizing PyLadies Vienna. So I would say we make a fluid change to Tina. Fabian, thank you so much. Bye.
Thank you.
Hello.
Hello, Tina. Glad to have you. How are you?
I'm doing great. Thank you.
Perfect. So happy to hear that. So, Tina, you're organizing the PyLadies Vienna meetup, and you wanted to give us some more insights. Is that correct?
Yes, I would like to introduce a bit what we are doing as a PyLadies in Vienna and how all of you can join us in our mission.
All right, Tina, stage is yours.
Thank you. So, same as Fabian, I'm working in an EX company, and I'm working as a geospatial data scientist. And I feel that there is still a bit of a need to promoting that IT is not only for men, but also women plus can join us. So we started the PyLadies chapter in Vienna, and today I would like to tell you more about PyLadies and mentoring. So who are the PyLadies? Because maybe not all of you know that. PyLadies are international mentorship group with a focus on helping more women plus become active participants and leaders in the Python open source community. This is pretty general, and PyLadies as an international community consists of many local chapters, and one of these local chapters is PyLadies Vienna, where we can do the stuff how we want. So what we are doing here, we are mainly focusing on organizing beginner courses where we are taking complete beginners, and during the 4 or 5 months, we are trying to teach them all the basics of the Python. We also did one PyData course where we tried to explain the basics of a machine learning together with how to do the visualization and basics of statistics. We are organizing shorter coding sessions where everyone can meet and code together, get help, just discuss the issues together. And it is also a nice event for networking. We used to do a lot of Saturday workshops where we discussed many topics. But once we reached more advanced topics like Fabian's concurrency issue or how to build your Flask API, we found out that there is a huge demand for beginner lessons, and currently there is not so many women who feel comfortable saying that they are advanced in Python. So that's why we are currently focusing primarily on the beginners, but we would like to again get more into advanced users events. On the February, we are planning to launch our first hackathon, so I hope to see more of you there. This is our team. So I'm the main organizer together with Lubo, and recently Fabian joined us. You can see us here together with Aya, Severina, and Daria, who I still do not have pictures of them, but they are also valid members of our organizational team. And we hope to grow even more. Now I would like to tell you a bit more about what are our Python courses consisting of. So as I said, it's 14 sessions from complete beginners. Our only need to know how for application is if they know how to send an email or fill out the application, and we can teach them the rest. We are covering basic working with the command line, and we are ending with the classes topics or the APIs. There are many homeworks after each sessions and 2 bigger projects on the route to complete, which can be done in the group or alone. So we want to also learn them how to work in pairs or groups or communicate with other developers. But our course and basically PyLadies would not be possible without the mentors. Mentors are essential part of the PyLadies. We are all doing this in our free time. This is basically volunteer-run organization. And mentors has the crucial role during the course. They are teaching during the lesson. They are explaining all the hard topics. So without them, you would have to just self-study. They are also giving a feedback to the homeworks, which is crucial part for learning from your own mistakes, or just the tips and tricks how you can improve your code in terms of readability, speed, and other things. They are also supporting everyone in the channels with any problem. And we are so happy to have them, because this is allowing people to actually become really active participants in the Python community. The reason why we are doing this is because we value the human contact with the mentors and the mentees. And we found out that this is a crucial point in actually learning a new language and mastering such a skills, which can be seemed as a really hard and daunting at the beginning. Now you may ask, why to mentor? Why to volunteer your free time, which is so rare and so pricey, to something like teaching others? The first reason is obvious, because mentoring is fun, but all the other reasons apply as well. Mentoring others can expand your professional network, and it can be done online or offline, and building your professional network and maybe even transform these connections into friend network is always valuable. You can also improve your communication skills, because we all know that explaining some harder topics can be a real challenge. And if you learn how to communicate the hard topics in a simple language that all the beginners can understand it, this is really valuable. You can also learn how to structure goals, not only your goals, but also the mentees or the attendees of our courses, and you can work on achieving them. This is really important also for your work life, and you can get this more via mentoring others. Also, it can happen that your knowledge and approaches will be challenged with fresh point of view, which is especially useful for if you are a senior and working in one company for many years. It is always good to get a fresh point of perspective, and younger professionals or juniors always have a different perspective on how to solve things, and maybe you will find out that actually there can be even better. And the last reason is simply learn more while teaching others. Maybe you experience that usually when you learn something, you really learn it when you are explaining to others. Now you would like to maybe be a mentor, and you're asking how to find your mentee. But before you get to that, I think it's important to describe yourself some of the other points. So first, you should list the skills you can offer. Is it a technical skills, or just the non-technical, like career advancement tips, or in general, what you are interested in? Also, you should determine really realistically how much time you can invest. It can usually happen that we are overestimating our time flexibility, and then we find out that we are not able to fully commit to something, and these relationships are not then fruitful enough. Then I would suggest offer your time to your junior colleagues, more junior, not only juniors, and help them succeed in the organization you are already active. You may find out that there are younger colleagues who are struggling to grasp more senior topics or how to advance, and they will be so grateful for having a helpful hand in their own known environment. If you do not have such a colleagues in your environment, you can definitely join our community, and we will be super helpful to have you here. We can use your skill in many various ways, and I will talk about it shortly. And what about if you are looking for a mentor, and you don't have to be a junior? Mid-careers and seniors are all the time looking for career advancement mentoring. So the steps are similar. Define what you want. Define what is it? Is it a technical skill development? Is it a career advancement, or just a simple networking? Once you know, it is easier to look for a relevant group of your focus and find the best mentors there. They can also try to find mentorship programs which are really narrow and focusing on a special thing. So if you are, like me, really into geospatial data, there are probably a mentorship program for geospatial professionals. If you are, as I said, working in a company already, ask your senior colleagues for more formalized mentorships. Why I'm saying formalized, the reason is that there could be some implicit expectation that the senior colleagues are mentoring the younger ones, but it may not be actually happening in real life. So ask for a more formalized form of this and try to summarize your goals on a paper and continue working on them. And how do we do that in the PyLadies in Vienna? As I said, we have mentors for the course being, and they are really valued part of our team. But we would like to offer also one-to-one mentoring for not only juniors, but also to mid-career levels and achieve them, help them achieve a better position in their professional life. We would like to match the mentors with the mentees based on their profiles, so we can ensure that they benefit this most. So we need people from various backgrounds with various focus, and also with the time flexibility if not everyone is located fully present in Vienna. The mentoring in PyLadies can be technical and non-technical, because for non-technical things, some questions or dreams are, how do I even start this career path? And just showing the way or discussing the steps needed in order to become a professional software developer are always welcome. We also plan to organize group events for all participants of mentoring, such as hackathons or career counseling, or building of soft skills like presenting your project or how to sell your value. So to sum it up, what to take home, mentoring is important. I think all of us remember when we were starting as a junior developers or programmers, or however you call your profession, it was tough. And having someone more senior showing us the way forward, or just someone we can trust and share with him our achievements or even our not so great achievements, it is really important. So try to remember about all these younger people there, and try to help them. Also, being a mentor is a two-way road, so it's not beneficial only for a mentee, but mentor, as I said previously, can take a lot from that, like expanding the network or really getting better in communication with others or non-technical people, which is good when you are not having only company of one person. And you don't have to just reach out to me, but first search for mentees and mentors in your organization. Maybe you will be surprised how many people are interested in. And lastly, join our community of PyLadies supporting Women Plus on their way through IT and helping them get into the IT in the first place. If you are now interested, you can check for updates on our website, PyLadies.at, where we will open the call for mentors quite soon. You can reach out to us on the PyLadies.Vienna Gmail. We are really fast in replying. And you can follow us on Twitter or LinkedIn. You can also, of course, follow our meetup group, which is quite dormant right now because we moved to other platforms. And if you want, you can join our community on Discord. Thank you very much.
Hi, Tina. Welcome back on live stage. Thank you so much for sharing all this information with you, and a special thank you for you and your team to contributing so much to the developer scene. So if you are in Vienna or in the surroundings, just follow them on social media, and we also link them in the speaker details in our live page. I am sure they will gladly answer all your questions. So Tina, thanks again, and see you next time. Bye.
Bye.
And as this topic day also slowly comes to an end, I have some informations and reminders to share with you. First, don't forget about our 2 raffles I announced at the beginning. First, in partnership with Deloitte, we want to give out to you a MetaQuest 2 VR gaming headset, or one of 10 goodie bags. To sign up, just scroll down at the live page and you're good to go. And secondly, we want to hand out to you 2 signed Dax from Hakon Guillaume Lee, the inventor of CSS. For that, go to our Twitter. There you can participate in a naming competition, and the winner gets 1 duck. And for the second, just sign up to our Dev Digest newsletter, and we will raffle it out through all of the subscriptions there. Also, don't forget to go to wearedevelopers.com/live to look up the coming live days from this season and register for free. Or if you even want to have a talk on yourself, just hand in your paper. You can also do that on our live page under the call for paper section. And if you're still looking for your dream job, remember, we have a job platform. Just go to wearedevelopers.com. We have listed a lot of jobs from all over Europe, and most of them with upfront salary information. And after that, one of our beloved colleagues has her birthday today. So Claudia, happiest of birthdays from all the team. Have a nice day. And now to the audience, I hope you all have a great rest of the day. Thank you so much for participating in today's Python Day, and see you all again on October the 19th, when it's all about DevOps. Bye.
Have you found your dream job as a developer? Or are you stuck in an unfulfilling job? On WeAreDevelopers.com, you find over 1,000 jobs in Europe that fit the tech stack that you want to work with, and salaries go up to $130K. All you have to do is create a free profile, and you automatically get matched with jobs that fit your requirements. So what are you waiting for? Create your free profile and let companies apply to you now.